Hello everybody, I hope you are doing well. I'm sure you would have been told do not play with electricity. If you play with electricity, it is dangerous. But today we are going to play with this electricity chapter and become the players of it. So you must have read this electricity chapter via your book. Teachers would have taught you, you would have seen some YouTube videos, etc., etc. But still, just looking at this chapter gives you shocks. Shock laga. So today we are going to get over all those shocks after this video, where I'm going to talk about all the concepts of NCERT, all the questions of NCERT, various questions of the boards, specifically from electricity, and you would be ready for any exam that you are going to give. It be your midterm, it be your pre-board, it be your boards, everything is going to be solved if you go through entire video. Okay, so here we begin with the chapter electricity. Don't be scared of electricity. It is very simple. So we are going to study charge, electric current, potential difference, Ohm's law, resistance, series and parallel combination of resistance, electrical circuit, electric power and energy, and Joule's law, heating effects of current. So let us start and see with the first topic, which is charge. Okay, so here we go, charge. Okay, so let us begin with this chapter of electricity. So what is electricity? Now understand very basic part of it. Electricity is flow of charges in a conductor. The entire electricity is based upon this. Flow of charges in a conductor. Write it down somewhere and we are going to come back to this particular concept. So moving ahead to the first chapter or the first topic, which is charge. So what is charge? Basically, charge is the property of a body to attract other bodies. Charge is property of matter that causes it to attract or repel other objects. Now you must have heard that people were stuck in power, electrical lines. Why? Because those lines have got charge. They attract you. So you have to stay away from them a considerable distance. You would have seen that, a comb when rubbed on the head, it attracts the various small tiny papers. Why? Because it becomes charged. And sometimes you have people who have got charged personalities and you're attracted towards them. Hey, be attracted towards the studies, okay? Let's go ahead. Now, talking about charge, property of matter that causes it to attract or repel. Charges can be of two types. One is positive. We denote positive charge with this. Other is negative. We denote negative charge as this. Plus and minus. Opposite charges attract and similar charges repel. That means if I have got two charges, positive and positive, they will repel each other. If you have got two charges, negative and negative, what will they do? They will also repel each other. If we have got positive and negative charges, these charges are going to attract each other. So opposite charges attract and similar repel. Now the unit of charge or SI unit of charge is coulomb, which is denoted by C, and charge is actually can be written by Q. So charge is denoted by Q and SI unit of charge, which is coulomb, is denoted by C, because Coulomb was the scientist and the unit has been named on the Coulomb's name. Something very critical. Now, what is this charge made of? The charge is made of the most fundamental, basic, smallest independent charge, which is the charge of electron, which is charge of electron. So electron has got a negative charge and it has got a very, very, very small charge. How small? Let me tell you. The charge on electron is 1.67 into 10 to the power minus 19 coulombs. So that is the charge on an electron, 1.6 into 10 to the power minus 19 coulomb. Now if I ask you a question, quick question, how many electrons are in 1 coulomb? Please answer that. How many electrons in 1 coulomb? So it's very simple. Electron has got 1.67 10 to the power minus 19 charge. So 1 upon this charge will give you total number of electrons in 1 coulomb. Answer that question in the comments. Give me the answer of that question in the comments. All right, moving ahead. After charge we go to, after charge we have to go to, it's here. After charge we will go to the next topic, which is electric current. Now remember what we talked about? Flow of charges, electric current, simple. Flow of charges is electric current. So here it says electric current is the rate of flow of positive, we'll see that, charge in a conductor. Now remember one thing. In many definitions you would find something called rate. The moment rate comes in, rate of flow of charge, you put T in the denominator. We'll see how. So rate of change of distance is d upon t is exactly speed. Rate of change of velocity is acceleration. So it is what, AD sir, this is electricity, you are teaching motion. Don't worry, physics, everything is related. So rate of flow of positive charge. Now let us see a small, explanation of this. Now here, if this is a conductor, now if this is a conductor and assume that all the electrons by something, we'll get to know by what, are flowing in this direction. They are flowing in this direction. Now electron is negatively charged. So if electron is flowing or negative charge is flowing towards this direction, the positive charge will flow in which direction? Of course, positive charge will flow in opposite direction, this direction. So electron flowing in this direction, the positive charge flowing in this direction. And what is the definition that we have read here? Electric current is the rate of flow of positive charges in a conductor. So what does that mean? Which direction does the electron flow? The current flows in the opposite direction. So direction of current is opposite to the flow of electron. Electron going this way, current going this way. This way, this way. Electron going this way, current going this way. This way. No, it's not a hug. It is the direction of electron this way and current this way. So in case if you find somebody is asking if there is an electron which is going in this direction or electron is going in upward direction, then the current flow would be in downward direction. We denote current by I, right? We'll just see that. So you got this concept wherein the flow of positive charge, rate of flow of positive charge in a conductor is electric current, and the direction of current is opposite to the flow of electrons. Okay, now let's go ahead. in defining the formula of current. Like we said, electric current is rate of flow of charges. For a moment, let's keep positive away for a moment. So current is, the current is charge divided by time. Current is charge divided by time, because it is rate of flow of current, rate of flow of charges. Rate, if rate comes, time. Now this current is measured in amperes. Charge is measured in coulombs. We just saw that, right? And time is measured in seconds. Please remember this. So I is equal to Q by T. Now wherever in this slide you find this red box, that means it's a very, very important formula. Note it down immediately in the copy. Now I is equal to Q by T. That means current is equal to charge upon time. SI unit of current is ampere. SI unit of charge is coulomb. SI unit here used for time is seconds. So remember that. So I is equal to Q by T. So I is equal to Q by T. You can also write is Q is equal to I into T. Q is equal to I into T. Now, what happens is the current is measured in amperes, but sometimes, in the instruments, we measure currents in different units also. One of them is microampere, milliampere, not microampere, MA, which is milliampere. Milliampere. So what is milli? Hey, not that milli which you are thinking, huh? Milliampere is millimeter. True? Milli. Milliliter. Milli. That milli. So similarly, milliampere. So which is 10 to the power of minus 3. So 1 milliampere is equal to 10 to the power minus 3 ampere. This is microampere. Micro is an even smaller unit, which is 10 to the power minus 6. Alright. So we understood about the current, that current is the rate of flow of positive charge in a conductor. Current's formula is I is equal to Q by T. Q is equal to I into T. You just take it there. SI unit of current is ampere, charge coulomb, and time second. Let's move ahead. Let's solve the question here. Now this question is a very simple question. Just a walk in the park. Simple question. It says an electric source can supply a charge of 500 coulomb if the current drawn by the device is 25 milliampere. Find the time in which electric source will be discharged completely. And this question came in CBSE 2024. Now imagine such an easy question comes from the chapter of electricity. Sometimes difficult questions will also come, but sometimes it's an easy question that comes in. So let us solve this. So Q given is 500 coulomb, and then I, which is the current given, is 25 milliampere. Remember, milliampere. So what, and we have to find, what do we have to find is, we have to find the T. Simple question, no complication, simple formula based question. So Q is equal to I into T. You remember? Q is equal to I into T. Q is given 500, I is given 25 into 10 ki power minus 3 ampere into T. T is to be found. Please find out the T. T is equal to 500 upon 25 into 10 power minus 3. We cancel this, this becomes 20, and you take this up, it will become 20 into 10 raised to the power of 3, which would be equal to 20,000 seconds. Got it? Simple question, it came in the board, so please remember this formula. Q is equal to I into T or I is equal to Q by T. Let's move ahead. Now the question is how to measure electric current. Very simple. This comes directly into the examination. They ask you which instrument do you utilize to basically measure the current. Name is ammeter. Ampere, the unit of current is ampere. So this particular instrument is ammeter. Ammeter is always connected in series. So this is here is ammeter, it is connected in series. Right now just remember it. We'll talk about series, parallel and everything. Few things you have to remember also in physics. I mean, you remembered ABCD also, na? You remember 2 1s are 2, 2 2s are 4, 2 3s are 6. You remember that? Few things you have to remember. Things remember, ammeter is connected in series. Ammeter has very low resistance. We take reading in ampere, milliampere, microampere. All of these things are there. Now we have a very low resistance because there is a reason for it. Ammeter needs to measure the current. If ammeter eats all the current, does ammeter eat current? There is something that eats current. Yes, it does. We'll talk about that later. So again, things to remember. Understand, we have talked, things to remember. So remember is it has got a very low resistance. We'll learn about that little later, but right now put that into the notebook and remember the basics of current. Now after current is done, let's go to another thing, which is potential difference. Now what is potential difference? Now imagine when we say difference means minus. Subtract, find the difference between two values. You must have heard that about in your polynomials, in your mathematics. So difference means values. So when it says difference, there are two values. Two values here are 2 points. Now see, there are 2 points here. Point Y and point X. Now if I have to put something, anything, I have to take it from X and put it to Y. If I have to take anything, I take it from X point to Y. I will need to do some work, right? Like your mom says you, go ahead and clean your room. You have to pick something from your room and put it somewhere else where it is required to be kept. You have to do some work, right? Your father says you, go ahead and get me something from the market. So you go there, buy that thing, bring it up, keep it at your home. You do some work. And still my mother says I don't do any work. Sure, your mother also. So coming back, so if I pick up something from one point and put it to other, I am doing some work. So potential difference, you pick up a charge. You pick up a charge, 1 unit charge, and put it on the other place, other point. So the work done in taking the charge from one point to another is called potential difference in both the points. So potential difference between 2 points is the work done to move a unit charge from one point to another. Okay, and how do we put the formula of potential difference? Just like it is written there, very simple. Potential difference is equal to work done upon charge. Now remember, the units of work done is joule. It is represented by, once again, it is joule. It is represented by J. Unit of charge is coulombs. We know it is represented by C. Unit of potential difference is volts. Unit of potential difference is volts and it is denoted by V. So what does the formula in the red box? Formula in the red box. Red box says V is equal to W upon Q, where W is the work done and Q is the charge. So SI unit of potential difference is volt, and potential difference, remember one more thing, potential difference is also called, voltage. Potential difference is also called voltage. Have you heard about various electrical components are operating at different voltage. So potential difference is also called voltage. Clear? So two things, one is current, next is potential difference. Now let's go ahead and try solving some questions here. I'll come to this later. So it says, this question came in CBSE 2025, right? See how simple the question is. It says define the term potential difference. Can you define the term potential difference? The work done in moving one unit positive charge from one point to another point is potential difference between 2 points. Name and define SI. So name is volt, define we'll come to it, right? Name of the SI unit is volt. Also expressed in terms of unit of work and charge. Unit of work and charge. So V is equal to W upon Q. It is asking express in terms of SI unit of work and charge. So work SI unit is joules, charge is coulomb. So they can be said joules C minus 1 or joules by coulomb. Clear? Let's go to the next question. Now this is a very simple question. Easy peasy, lemon squeezy. Calculate the work done in moving a charge of 6 coulombs from point of 220 volts to another point at 250 volts. Okay. So calculate the work done in moving a charge of 6 coulombs from a point at 220 volts to another at 250 volts. Another, what is the formula of potential difference? V is equal to W upon Q, where V is potential difference. Potential difference means 2 points. Are there 2 points in the question? Let us find out. So yes, there is one point, point A, which is at 220 volts. Then there is a point B, which is at 250 volts. So tell me, what is the potential difference? So potential difference would be 250 minus 220. Here would be 30 what? 30 volts. So I've got V. Potential difference ke liye V, I have got 30 volts. Now we have to find out, calculate the work done, which is W. Moving the charge, what is the charge? Charge that is given, Q is given as 6 coulombs. Charge is given 6 coulombs. Potential difference is taken out. So what is the work? So work is equal to V into Q. Here the work would be, V is potential difference 30, Q is 6. So this is 180 what? Joules. 180 joules. Clear? Let me get some water. Huh? Okay guys, you also take a break. It's important to take breaks. If you take breaks and keep on remembering what you have studied, your retention power increases. But that does not mean you are always on break. You have to study and then take break. Okay? Go for a break. Very nice. Okay, coming back. How to measure potential difference? So how are we going to measure potential difference? We measured current as via ammeter. We measure potential difference by voltmeter. We connect voltmeter across the wire. It is called parallel also. We'll study about parallel and those things. Okay. Voltmeter is connected in parallel. Things to remember. Voltmeter is connected in parallel. Has got very high resistance. We take the reading of voltmeter in volts, right? And potential difference is also called as voltage. Okay, it is also called as voltage. So we have studied a few things. We have studied potential difference. We have studied current. Do you already feel like a player playing with current, charges and potential difference? No, Baba, we are still not player. But yes, we are learning the rules of game. So learn the rules of game here. So we are going to go ahead for the next. We've already studied this slide. Now let us understand, why are we studying this potential difference? What is the use of potential difference? Now, the use of potential difference is to make sure that the current flows. Right? The use of potential difference to make the current flow. Okay, understand. We have learned one thing, that flow of current is flow of charges. Correct. So how does anything flow? So you stand on top of stairs. If you fall, fadak, down. If it's a straight plain surface, will you fall? Some people fall on plain surfaces also, but usually they do not. In a waterfall, something from the top, which is water, falls down. So everywhere we see something which is at a height makes things flow. So if we consider this particular bottle, the bottle is full, correct. This particular bottle has got some water. So the level on the water here is lower than the level of the water here. Level of the water here is lower than the level of water here. So you would see that water is flowing from this bottle to this bottle. Because here it is at height, it will flow. You would have seen this. Now it's very, very normal, natural phenomena that the water is flowing from which has got higher level to the lower level. Until when will it flow? Tell me in the comments, till when will it flow? Exactly, it is going to flow till both of them come at the equal level. That means there is no difference. There is no difference. Similarly, the current will flow from one point to another only if there is a potential difference. You got it? Only if there is a potential difference. And potential difference causes the current to flow is a rule. So in case if there are say two points, point X and point Y, and both of them have got potential difference V. This is Y. Y. Potential difference V. Both of them have got potential difference V. So there is no difference. There is no difference. So there is no current if V and V are equal. Now if this V becomes V1, this becomes V2, they become difference, there is a potential difference. Moment the potential difference is there, the current will flow. Clear? Simple. So if the current has to flow, the potential difference has to be there. So here we see this is a cell. You have those normal cells. I mean the ones that you use in torch, the one that you use in watch, the one that you use in many places, right? In these cells there is one positive and there is one negative. Oh, this is negative. One which is negative. Now the moment we have positive and negative, there is a difference. This cell creates a potential difference. And what happens if I say that this is positive, this is negative, and this is a conductor? The current will flow from higher to lower. The current will flow from higher to lower. So here we have plus. Plus is, if I say plus is at a higher potential and minus is at a lower potential. So tell me quickly where the current will flow from. The current is going to flow from, exactly, from the higher potential to lower potential. From the higher potential to lower potential. And flow of current is flow of positive charge. Flow of current is flow of positive charge. So if we have flow of current this way, a positive charge coming this way, it doesn't go. It doesn't go. The flow of current, positive charges don't flow. It is flow of current is this way. If flow of current is this way, then electron flows opposite to the flow. Remember, say positive charges don't flow. It is just the electrons which flow. So if the current is from this direction to this direction, then the electrons are going to flow from, electrons will flow from this direction to this direction. That is how and that is where the electrons will flow, right? So remember, the current will flow only if there is a potential difference, and it flows from higher potential to lower potential. So in case if there is a question that says if the current or the direction of current is from left to right, If the direction of current is from left to right, the direction of electrons will be from right to left. It is opposite. It is opposite. Please remember that. Okay. Now let's go and talk about this particular thing which we call cell. We also call cell as battery, correct? But cell and battery are different. A single cell is denoted by this. This is positive, this is negative. A single cell is denoted by this. It may have a potential difference of say 2 volts. It has a potential difference of 2 volts. Now if I connect these two cells together or more cells together, how do we connect? This is positive, this is negative. You connect this negative to this positive, then negative. It is very simple. Big, small, dash, big, small. So the bigger line is positive, the smaller line is negative. I have connected two cells together. The moment you are connecting cells together, you make a battery, right? So cell is an individual thing, and then you make a battery by connecting different cells. So now the question is, AD sir, if this battery is 2 volt, if this cell is 2 volt and this cell is 2 volt, what is the potential difference of the battery? So very simple. Tiny, miny, itsy, bitsy, easy peasy, lemon squeezy. You add 2 volt and you add these 2 volt. You add 2 volt plus 2 volt. Then what you get? You get 4 volt, which is the potential difference of the battery. Which is the potential difference of the battery. Clear? You got it, guys? So it is very, very simple and important to know that current will flow only when potential difference is there. Potential difference causes the current to flow. Current will flow from higher potential to lower potential, and the flow of electron is opposite to the current. So you remember this, electrons will flow from lower potential to higher potential. Electrons will flow from lower potential to higher potential. Okay. So till now we have understood the current, till now we have understood the voltage or the potential difference. Are you guys enjoying this? Are you guys seeing yourself playing with current, playing with voltage, playing with all the electricity charge, right? So in case if you guys are liking it, I have a request, and the request is, if you have liked it, please subscribe to this channel and forward this particular video to your friend who really is struggling in electricity. And in case they want to study, they can study with you, they can study with AD sir, that is me, and they also can become the players, and then both of you become players and play with this chapter. But actual electricity, don't play it or you will get a shock. Okay? Okay, let's go ahead to the next particular topic, which is resistance. Now, the word resistance you would have heard in social studies also, right? What is the resistance in social studies? When people are resisting one particular rule or one particular government, they are against it. They are against a government. Then French resistance must be your, French Revolution, French Revolution is a chapter that you have in social studies, long chapter. Believe me, on this channel, you will learn about that, right? There is Tanvi ma'am who will come and teach you about the French Revolution. So we also call it resistance. So understand, resistance is something which is getting opposed. If you are getting opposed, then you are getting resistance. Say for example, you are in the interval. Everybody in interval just goes out, runs and has some fun. Few people don't. Leave those people. But everybody who likes to play will go out in the interval, and will see in a corridor there are a lot of students are there. So if a lot of students are there and you start running, and then somebody is going to bounce you back, somebody will bounce you back, and you would be like and you'll reach other side. So you see that the people in the corridor are opposing your flow, opposing your motion. They are giving you resistance. Understood? That is basically resistance. Now let's see what is resistance in electricity. Resistance. So what happens? Electrons flow, you remember, electrons flow. So when the electrons are flowing in a conductor, say this is a conductor and say this is silver conductor, right? Electrons are flowing in silver wire, silver metal. So this is an electron, this is electron, this is electron, this is electron, this is electron. So this electron is flowing and is being resisted and is being knocked out by other atoms of the conductor or silver metal. So when electron is flowing, it is being resisted. So the flow of electron is being resisted by the atoms, and this generates the resistance, right? Understood? Simple thing. Now imagine you being in a very, very dense corridor, then you'll have more resistance. If the corridor is empty, you'll have less resistance. Similarly, we are going to talk about on what things the resistance depends upon. Okay? Resistance. So now resistance basically is, let's see, the resistance of a conductor is the property that opposes the flow of electric current. Resistance of a conductor is the property that opposes the flow of current. See, it is opposing the flow. Now, what all this property depends upon? It is dependent upon the length of the conductor. It is dependent on the length of the conductor, and says resistance is directly proportional to the length. Now, if this corridor becomes longer, resistance will increase. You will face more people dhudum, 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 dhudum going there. The resistance will increase. So, resistance is directly proportional to the length of the conductor. Then, other thing which the resistance depends upon is the cross section area. Now, what is cross section area? What is cross section area? Say there is this wire. Say there is this wire. Now in this wire, say, okay, let's say this is a wire. If I cut this, then I'll have this surface. Then this surface is called cross section. Okay. If I cut this, I'll have this section. This is called cross section. So resistance cross-sectional resistance is inversely proportional to area. That means if you increase the area, resistance will decrease. So here, if this conductor's cross-section increases, the resistance that you face from the people will decrease. So resistance is inversely proportional to the area cross-section. Third thing it depends upon is nature of the material. That means the resistance is also dependent upon what type of material you are using for conductor. I mean, like in rubber, if you have a rubber conductor, there will be no resistance, there will be no flow of current. In wood, there is no flow of current. Wherein in metals, there is flow of current. It is copper, it is aluminum. In silver is the best conductor of the electricity. Yeah? So if there is nature of the material comes into play, and we call it resistivity. We call it rho, or we call it resistivity. So resistance of a material is directly proportional to resistivity also, resistivity rho. And if I combine all these three, then it comes as R is equal to rho. This is rho. It's not P, it is rho. It is denoted like this, right? R is equal to rho L upon A, because R is directly proportional to rho, R is directly proportional to L, and R is inversely proportional to area A. So R is equal to rho L upon A. You got it? So how is this, what are the units that you come out of in resistance? Now, this is a very, very important question, and it is being asked. It is being asked that R, find out the SI unit of R using rho, L and A. So this is rho, huh? This is rho. This has to be written like this. This is rho. Forget about P. This is rho L by A. It is written as rho. Okay. So now our standard SI unit is ohm. Rho we will find out. L, it is always taken in meter, and this is A, which is area, it is in meter square. So it is in, this is in meter, this is in meter square, meter square. Now a question comes in the exam which talks about the resistivity, which is rho, and it asks you find out the SI unit of resistivity, which is rho. Now see here, I have R is equal to rho L upon A. Now what I can do is I can keep rho here and take this here, and I can put L here. Simple. So then this rho, rho. Arey, not that rho, it is rho, you don't cry, it is simple, it is very, very simple. We call it rho. Rho. So which is like this, rho, right? Rho is equal to AR upon L. Now let us find out the unit for rho. Now this is A is to be taken as, so this is like, if this is rho, if this is rho, if this is rho, if this is rho is equal to A. What is the unit of A? A's unit is meter square. A's unit is meter square, and R's unit is ohm. R's unit is ohm, and then L's unit is again meter. So I cancel this 1 meter with this. So the unit of resistivity is ohm meter. Unit of resistivity is ohm meter. You can write it like this also, ohm meter. Unit of resistivity is ohm meter. Now next thing comes upon is something which is written here is temperature. Is resistance dependent upon temperature? I would say yes it is, and sometimes no it is not. But for our own understanding, I would say the resistance depends upon the temperature. If it is metals, then you increase the temperature. If temperature increases, then the resistance in metal also will increase. If the temperature increases, the resistance in metal will increase. Next thing is, if it is alloy, name an alloy. You must have read in chemistry, alloy. So let us say an alloy which is used in electrical circuits, alloy which is nichrome, nickel and chromium. You mix nickel and chromium, you get alloy. So if you increase the temperature of alloys, the resistance will increase, but not that much. In metal it will increase. In alloy it will increase a little bit. Okay. So that's what is about the resistance. Resistance is dependent upon length. It is directly proportional to L. It is inversely proportional to cross section area. It is directly proportional to the resistivity. So if I may just rub all this, so I will say R resistance is equal to rho L upon A. R is equal to rho L upon A. Similarly, with that, rho, I am very bad at drawing this rho. Please excuse me, huh? You guys make it good. Rho is equal to A R upon L. So this comes out to be ohm meter, because area is meter square, resistance is ohm upon meter. You cut meter, it is ohm meter. You also write it like ohm meter. Okay. Now the SI unit of resistance is ohm meter, is ohm. Sorry, SI unit of resistance is ohm. It is denoted by this. That's what we have used here. Okay, got it about the resistance. Now the next topic is the questions that we are going to solve upon for the for this resistivity. Now see, in CBSE 2023, this question came in: the resistance of a conducting wire does not depend on its resistance of a conducting wire does not depend on its length, shape, area, cross section or material. Let us see what is the formula of resistance. R is equal to rho L by A. Is it dependent on the material? Yes. Area cross section is also there. Length is also there. The only thing which is not here, shape is not here. So the resistance of conducting wire does not depend upon the shape. This would be the answer. Okay. Now see, the next question that came in 3 years. 3 years continuously was 2023, 2024, 2025, which says that write the relation between resistance R, the resistivity rho of the material of a conductor in the shape of a wire of length L and cross section A. Arey simple baba. It is asking a relationship between resistance, resistivity, length and A. And this hence derive the SI unit of resistivity. Simple, easy peasy, lemon squeezy. Let's see the same formula we have here. Okay. So here we have R is equal to rho L by A. This is the answer to the first one. Find relation between resistance, which is R, resistivity, which is rho, length, which is L, area cross section A. This is the first answer. Simple. See how simple questions are asked? Just need to understand the basic. Start playing, bro. Start playing. Hence derive the SI unit of resistivity. Very simple. What is resistivity? Resistivity is rho. Resistivity is rho. Rho is equal to R into A upon L. We just solved it. R is ohm, A is meter square and length is meter. This meter gets cancelled. The SI unit of resistivity is ohm meter. Got it? Simple questions, but these are very important questions. Please remember this. Okay. Now we move ahead to finding and checking about resistivity. Now what is resistivity? What exactly is resistivity? Resistivity is basically nature of a material. It is the natural tendency of the material. So you say resistivity is a constant of proportionality and is called the electrical resistivity of the material of the conductor. It is nature, material of the conductor. The unit is ohm meter. Very, very important. It is a property of the material and does not change the shape, size of the material. Resistivity is the property of the material, not that property, no flat, no lands, property, inherent habit. So resistivity is a property of the material and does not change with shape and size of the material. Does not change with shape and size of the material. So if this is a pen, its shape is like a cylinder and it has got a resistivity rho. I crush this pen and make it a ball. What will be the resistivity? Rho. I break it and make it a big wire. What will be the resistivity? Rho. So the resistivity is the nature of the material or property of the material, does not change with shape and size. Now, let's see highest to lowest resistivity. How does it matter? You remember resistance is directly proportional to resistivity. So higher the resistivity, higher the resistance. It is directly proportional. So let's see the highest to lowest resistivity. Insulator has the highest resistivity. That means insulator has the highest resistance. That means insulator, if has got highest resistance, so it will not let the current to pass. So highest to lowest resistivity, insulator is the highest. Then come the alloy. You remember alloys? Alloys, chemistry, all connection, electric connection between alloys in chemistry and alloys in electricity. and then the metals. So metals have the lowest resistance, metals have the lowest resistivity. Alloys have medium resistivity, medium resistance, and these insulators have got the highest resistivity, highest resistance. So in case you have to make a conductor where you need lesser resistance, please use metals. Metals are used in wirings, copper, aluminum, these are wires, because you need lesser resistance, you need current to flow smoothly. Insulators are like rubber, plastic, etc. So they have got very high resistivity, high resistance. That's where you'll find electricians using rubber gloves. Mama says na कि if you are going to touch the wire, wear rubber chappals, because that does not let the current flow. And SI unit of resistivity is ohm meter. Clear? Now this question came in CBSE 2025. Based on the table below, tell which one is a metal, alloy and insulator. Now material A has got resistivity of 10 to the power of 17. It has got the resistivity of 10 power 17. B has got resistivity of 44 into 10's power minus 6, and C has got 1.62 into 10's power minus 8. Now tell me which one of these has got highest resistivity? Which one of these, A, B or C? Put it in the comment. Which one has got highest resistivity? So highest resistivity is 10 to the power of 17. This has got the highest resistivity. Highest resistivity here is 10 to the power of 17. This is the highest resistivity, 10 to the power of 17. Then we have 10 to the power minus 6 is larger, or 10 to the power minus 8 is larger. Then we come to 10 to the power of minus 6, and then we have 10 to the power minus 8. This is the lowest. So C has the lowest resistivity. So this is going to be a metal. C would be a metal, B would be an alloy, and our dear A would be an insulator. A would be insulator. So very simple concept, that higher the resistivity, higher the resistance, was checked by CBSE in 2025. Right now, right now it was checked. Okay, so now we have understood about the resistivity. Now let us go ahead and solve some problems. Now see, this problem came in CBSE 2021, 2022, 23, 25. So it's a very important problem. Let's see. It says the resistance of metal wire of length 3 meter is 60 ohm. If the area cross section of the wire is 4 into 10 to the power minus 7 square meter, calculate the electrical resistivity. That is first part of the question. Let's solve the first part of the question. It says we need to find out the electrical resistivity. So R is equal to rho L by A. Okay. What all is given? We have been given R. R is given, what is R? R is given 60 ohm. Resistivity is given. How much is the resistivity? 4 into 10's power minus 7. No, that is not resistivity. That is the area of cross section of wire. Sorry. So, So area of cross section of wire, is 4 into 10 to the power minus 7 meter square. It says calculate the electrical resistivity, and length is also given. Length given is 3 meter. So it is asking us to calculate the electrical resistivity. Resistivity is rho, and R is equal to rho L by A. So with that we can write rho is equal to R into A upon L. Simple. What is R? Let us put the values out there. R given is 60 ohm. 60 into area which is given 4 into 10 power minus 7, and the length is given as 3 meter. Simple calculation question. I remove 3, this is 20, this becomes 80 into 10's power minus 7, 20 into 4 is 80, which can be written as 8 into 10's power minus 6. You cancel 1 0, and the unit of resistivity is ohm meter. Clear? Simple question. The next part of the question is, how will the resistivity of the wire change? How will the resistivity of the wire change if the length and the diameter of wire both are doubled? What is asked? Resistivity. What is the answer? Resistivity will not change. Why? Because resistivity is not dependent upon the length, area, cross section, etc. It is the property of the material. What is dependent on that is resistance. So here the answer would be the resistivity of the wire will not change because it is not dependent upon the physical dimensions of the material. Okay, let's go ahead. Second question. Now these questions are important because they have come in board examination. Just be with me, we will go slowly and we are going to solve all the questions out there. Okay, don't panic, just read them carefully. In the following figure, 3 cylindrical conductors A, B, C are shown along with their length L, L by 2 and L by 2, and areas of cross section. If they are made of same material, now it has given a hint to you. If they are made of same material, find RA upon RB and RA upon RC. Now once again, we are going to write our formula for resistance, which includes resistivity. So R is equal to rho L by A. This is the formula that you have to remember. Okay, now let us assume that the resistance of A, B, C are RA, RB and RC. Okay, so here it is RA is equal to rho L by A. This is the area of cross section, this is the length. Okay, what would be the resistance for RB or the material cylinder B? RB would be equal to rho L by 2 upon A, which will be equal to rho L upon 2A. Okay, which will be rho L upon 2A. You take this 2 down. Okay. Third, RC. RC is equal to rho L by 2 upon A by 2. This by 2 gets cancelled, so it comes out to be rho L upon A. Now what do we need to calculate? We need to calculate RA upon RB and RA upon RC. Now RA rho L by A, RC again rho L by A. So RA upon RC is equal to rho L by A upon rho L by A. Cancel, cancel, this becomes 1 upon 1. Okay. Now what happens to RA upon RB? So RA upon RB, if you put RA upon RB is equal to rho L by A upon rho L by 2A. This would cancel and we'll get 1 upon 2. Sorry, this 2 will go upstairs. So sorry. This 2 will go upstairs. So this would be 2. The answer here would be 2. This would be RA upon RB would be equal to 2. Okay. Now see, since the length of RA is higher, So RA's resistance would be higher. Okay. Now we are going to go to the next question. Don't worry, keep on practicing these questions. They are important. They are very, very important. Next question says, a wire of given material having length L and area of cross section A has a resistance of 4 ohms. Find the resistance of another wire of the same material. Now, if it is said of the same material, what is same? Resistivity is the same, because resistivity is dependent upon the material. Having length L by 2 and area cross section of 2A. See the figure, it is self-explanatory here. This is area, this is 2 area, L by 2, same material. Okay, when the material is same, the resistivity remains the same. So in both the cases, there are a couple of ways of finding this, but let us find out our old dear formula, which is R is equal to rho L by A. Okay, let us say RA here. RA is equal to rho L by A. A is the area of cross section and L is the length. So rho will be equal to R A into A by L. This will go there, it will happen. So what is the value of RA? The value of RA given is 4 ohms. The resistance given is 4 ohm, which is equal to 4A by L. Okay, the resistivity of A is 4A by L. Let us do the same thing here. The resistance is RB is equal to rho L by 2 upon 2A. So this would be rho L upon 4A. See this, basic mathematics, rho L upon 4A. So here the rho would be, sorry, rho, it is not R. You guys don't make this mistake, okay? Sometimes it happens. So it is what it is. It is rho will be equal to RB into 4A upon L. Now, since the materials are the same, so rho of A will be equal to rho of B. We put it here. So rho of A is 4A by L. Rho of B is RB into 4A by L. This and this will get cancelled, it will remain 1. So RB is equal to 1 ohm. Okay, very important question, but keep in mind, wherever you are finding the same material, one thing is for sure, that the resistivity is going to be same. So that's a hint that you need to apply this formula, R is equal to rho L by A. Okay, all right, let us move ahead to the next question. You will say, Anshuman Sir, AD Sir, how many questions are you going us to make us practice? It is very important for you to practice all these questions so that all these formulas come to you naturally. You don't have to think about it. You read the question and the formula are there. Don't worry, everybody, even if you have not studied electricity before, just stay with me. You will become the player of electricity, not just the student. Okay, let's see the next question. Next question says, how much does the resistance change if the diameter of the wire is doubled? What is doubled? Diameter of the wire. Okay, so let us see one thing. R is equal to rho L by A, where A is the area. Since it is the cross section of a cylindrical area, right? So A length is given L. Area, what is area of a circle? Area of a circle is equal to pi r square. Correct? Area of the circle is pi r square. And what is the relationship between diameter and the radius? So we all know that radius is half of diameter. That means if radius is doubled, diameter is doubled, radius will also get doubled. They are directly proportional. So diameter is half of the radius is half of the diameter. So if we basically go ahead and put this value here, so R would be equal to rho L upon pi R square, right? R would be equal to rho L upon pi R square. Now see the relationship between R and the R square. This R is resistance and this R is the radius. Okay, so R and R, and next thought R. Good movie, huh? So R is equal to, not equal to, is inversely proportional to 1 by R square. That means if the radius is changed by any value, opposite effect in square will come on resistance. Oof, Eddie sir, what are you talking? Unable to understand this. Let's see this, okay? Now one thing is clear, if radius will increase, resistance will decrease because they are inversely proportional. So if radius is increasing, resistance will decrease. By how much we'll see. If resistance is decreasing, radius is decreasing, resistance will increase. Let's see by how much, okay? So here if R is equal to 1 by is proportional to 1 by R square, and this R becomes twice, then R would be proportional to, here if I do it, it will be 4 R square. So the resistance is going to reduce 4 times because it is inversely proportional to the square of the radius. Okay, so there are two things that we see here. One is that R is inversely proportional to the area. It's an area. So if area increases, R will decrease by the proportional amount. And with this we derive that R is inversely proportional to square of the radius. So if the radius becomes half or the radius doubles, how much will resistance change? So if radius is doubling, the resistance will get half? No, square of half. It will reduce by 4 times, okay, because it is square. Same, radius and diameters are in direct proportional, right? So whatever happens with radius, same thing will happen with diameter. So let us solve with this question which was in CBSE 2021. How much does the resistance change if the diameter of the wire is doubled? So if the diameter of the wire is doubled, resistance would be reduced by square of the doubling or square of that unit. So in this case, R will reduce by 1 by 4. Okay, you understood this? So in case area is not given, you do not need to get panic. In case area is not given, radius is given, diameter is given, both of these can be utilized to calculate. Okay, we'll see such questions right away. Okay, now this question says the resistance of the wire of 0.01 centimeter radius. Resistance of the wire of 0.01 centimeter radius is 10 ohms. If the resistivity is 50 into 10's power minus 8 ohm meter, find the length. Okay, let us again go back to that particular formula that we have resistance. Okay, so R is equal to rho L by A. Let us see what all values do we have. R is given as 10 ohm, we know that. resistivity is given as 50 into 10's power minus 8. Length is to be calculated, and area which is given is, area is not given. They have given radius in centimeter. Okay, now let us put it as area itself here. Okay, let's calculate the area here. The radius that is given is 0.01 centimeter. First thing we do is to convert this into meter. So we convert this into meter. So 0.01 into 10's power minus 2, which is equal to 1 into 10's power minus 4. So the radius I have got 1 into 10's power minus 4. What is the area? So area we know is pi r square. Let us put this here, pi into 10's power minus 4 square of this value, which will come as pi into 10's power minus 8. Pi into 10's power minus 8. Okay. Now let's substitute this value here. So 10, which was the resistance, is equal to 50 into 10's power minus 8 into L upon 10's pi into 10's power minus 8. This is the area. Okay, so L would be equal to pi into 10's power minus 8 upon 50 into 10's power minus 8. Okay, so we minus 8 gets cancelled into R. So this into R into 10. Okay, so this goes here, this goes here, this goes here, this goes here. Okay, now this 10 and this 5 cancelled. It is pi upon 5. So what is pi upon 5? Pi is 3.14 upon 5. So this would be equal to some 0.6 then 2, 0.62, approximately 0.62 what? This is length 0.62 meter. Okay, understood? Got it, guys? So this is how you are utilizing the radius, to form the area pi r square and then calculating it. All right, clear? Okay. The next question is, a copper wire has a diameter of 0.22 millimeter. Diameter, correct? There has to be a bulb lighten up in your mind. Diameter 0.22 millimeter and resistivity of 1.6 into 10's power minus 8 ohm meter. What will be the length of the wire to make the resistance of 14 ohms? Length of the wire. And then second part of question is also there. Okay, let us tackle the first part of question. Write down what all is given. So we have been given a diameter of 0.2 millimeter. Now first you convert this into meter, which would be equal to 0.2 into 10's power minus 3 meter. Let us make it easier, 2 into 10's power minus 4. This is the diameter, so radius would be, you divide by 2, 1 into 10's power minus 4. This is the radius. This is the radius. Now second thing that we have is resistivity. We have given rho is equal to 1.6 into 10's power minus 8. And they have also given the resistance. Resistance given is 14 ohm. So what is to be done? We have to calculate the length. Let us use that our dear formula. R is equal to rho L upon A. L would be equal to R into A upon rho. Please calculate this. Please calculate this. Calculate this and put the values and find it out. Okay. Put that into the comment section. What is the answer of this? I'm not going to put this. This is purely calculation based. Now you need to make those calculations. Let's see how much does the resistance change if the diameter of the wire is doubled. resistance change, diameter is doubled, radius is doubled, area square of it. So resistance will become 1/4. If you are unable to understand, put that into the comment. I'll explain this again. Okay, but a very simple question indeed, but it came in CBSE 2021, so important question, very, very important question. Okay, so till now we have understood charge, we have understood current, we have understood potential difference, we have understood the resistance, we have understood resistivity, and we have solved so many questions. We have solved so many questions out there. So the next topic that we are going to study is Ohm's law. It is not meditation, but it is a law which defines the relationship between voltage and current. So you remember when we are talking about the use of potential difference, higher the potential difference, higher the current. So the same thing, more potential difference applied, more current is released. So the same thing has been put into law, which is Ohm's law. The Ohm's law states that the current flowing through a conductor is directly proportional to the potential difference across its end. So say this is a conductor and this potential difference is V. If V is increased, I, which is the current flowing into it, will also increase. If V is increased, I is also increased. When this relationship between two entities is there, the more one moves, the more other moves, it is called directly proportional. For example, mummy gets angry on you. You do more mistakes, mama gets more angry. More mistakes, more angry. So your mistakes and mama's anger are directly proportional. Remember this. So Ohm's law says V is directly proportional to I. In order to make an equation into it, we write V is equal to I into R. V is equal to I into R. So what is V here? V here is potential difference and its unit is volts. I is the current and its SI unit is ampere. And R is the resistance. And we know that resistance SI unit is ohm. You also write it ohm. Oh, sorry, W. Ohm. We write it as ohm. So Ohm's law states that V, which is voltage, is directly proportional to I, which is current in a conductor. And then we have the equation is V is equal to I into R. So what is Ohm's law? Ohm's law is not V is equal to I into R. That's a formula, right? Ohm's law is that V is directly proportional to I and states that current flowing through a conductor is directly proportional to the potential difference across its ends. It says provided the temperature of conductor remains constant, because the resistance we know depends upon the temperature also, right? Resistance in metals and alloys basically is dependent upon the temperature. Remember it, higher the temperature, higher the resistance. Okay, this is called the Ohm's law. So the next thing that we are going to study is the slope. Now what is slope? It's a very simple thing. Slope basically, if I define it in terms of your understanding, is a ratio. In a graph, slope is the ratio of y-axis to x-axis. What is y-axis here? V is the y-axis. So here the slope would be found out by saying V upon I. I is the x-axis, V is the y-axis, V is the voltage, I is the current. And you remember that formula? You remember that formula? V is equal to I into R. So V is upon I would be equal to R. The formula was V is equal to I into R. So V upon I is R. Remember this. So this slope is this slope gives you basically the value of R. Now see and understand this. the way I am increasing V on y-axis, value of I is increasing on x-axis. Okay, so if V is here, I is here. If V is here, I is here, right? So because of this ratio, we get this as a straight line. Another thing that you have to, understand here is the slope is again basically the angle. Slope here is also represented by the angle which this line is making with the x-axis here. So if I have to increase this angle, I need to take that side, I need to make this sharper. If I make this sharper, then the value of I, which was here at this voltage, if I increase this, the I changes, right? So basically, the moment I am increasing this V or I am increasing the slope, this ratio R is changing, and the moment this slope increases, the value of R will increase. See, the inclination, the angle has increased, the value will increase. So the slope basically is the ratio between y-axis and x-axis, and can also be denoted, if the angle is higher, the slope is more. So if I say that this slope basically, this line basically goes ahead and defines R, which is the resistance. If I increase the slope, if I increase the angle, the resistance will increase. Remember this. Higher the angle, steeper the slope, higher the resistance in V and I graph. So a question comes like this. In your board, this question has come. The question is asking, amongst these three slopes, which slope basically tells the metals, alloys and insulator? Simple. Metals, alloys and insulator. We are aware that metals have got the lowest resistivity, that means lowest resistance, because our resistance is directly proportional to resistivity. And insulators have got the highest resistivity, that means the highest resistance. Okay, so let us see here. We have three. So this is first angle, then I have got this as the second angle, and then I have got this as the third angle. Just by looking, you can tell which angle is the highest or the largest, or where. So the R3 is the largest one. R3 is the largest one. That means R3 has got the highest resistance. And amongst alloys, metals and insulators, which has got the highest resistance? Insulators. So R3 is an insulator. R1 is between R3 and R2. So R2 would be metal. It has got the lowest resistance. So R2 would be a metal and R1 would be an alloy. This question can also come, explain and determine if this is resistance, talk about the resistivity. Very simple, higher the resistance, higher the resistivity. So if it is talking about resistivity, the answer would remain the same. This has got the highest resistivity, this has got the medium resistivity, this has got the lowest resistivity. Okay, all right. Now let us move ahead here. Okay. Next thing that it was asked, usually is asked in the examination, is experiment, which is Ohm's law. How was Ohm's law proven? So scientists basically need to prove anything. Now, if they have made a law, they would have done a lot of experiments to make something as law, so that it holds true in every other situation. Now, in order to set this up, you had to make an experimental setup. Now remember, this question comes in your exam, it comes for 3 to 4 marks. How are you going to recognize this question? Wherever it is written experiment and Ohm's law, if these two words are coming together and it is being asked to prove, to set up, to determine the experiment, this is what you have to do. First of all, you have to make this figure. Now let us see what is this figure. This figure is an electrical circuit. Don't worry, we are going to talk about electrical circuit after some time. Now this is a setup. what is the most important thing in an electrical circuit to begin with is the battery. You remember the battery? Battery is the combination of these cells. Cell, one big, small, big, small, big, small, big, small, big, small. So battery is the combination of all these cells, and we first set up a battery. So here, how many cells are being put here in this battery? Can somebody tell me here? Absolutely, there are 4 cells. Cell number 1, cell number 2, cell number 3, cell number 4. You are connecting them all together, it becomes a battery. Now you connect a wire and put something called A. What is this A? This is ammeter. What is ammeter used for? Ammeter is used for measuring the current in amperes, milliamperes and microamperes. Okay. Moving ahead, here we have got something called resistance. We are aware what resistance is, and we put voltage in parallel. We'll talk about series and parallel in a moment, but imagine, just understand, voltage is put hanging up here. Then we move ahead and we put something, this. What is this? This is basically the switch. You have got switch at your home, the plugs and the switches. You switch it on, light flows, switch it off, light goes off. This is a switch, and this switch is also called plug key. You see a dot here? Now, if this dot is present, that means the switch is on, the current should flow. If this dot is not there, the current will not flow. Now, what we have to do in this experiment, we have to note certain readings. What readings are we going to note here? Voltage and current. So, I have made a table here to note the voltage and current. This is the experimental setup diagram for Ohm's law. So, how did it happen? Now, see, you see this wire, this is hanging, it is not connected anywhere. That means the current is not flowing. So, first thing we do is we connect this. We connect this from here to here. We connect this. Now, if you watch carefully, the current is going to come from here, go here, pass through the ammeter, go here, pass through the resistance, go here, and then it will take this path. Why this path? Because this is the only path which is connected. It is going to take this path. Now, imagine if all these batteries are of 2 volt each. If all these batteries are of 2 volt each, right now in this circuit, what potential difference is applied? Just one battery, which is 2 volt. So, we write here as 2 volt. Now, imagining if 2 volt is been put here, 2 volt, the current that flows is 1 ampere. So, how did you measure that current? You measured that current with this ammeter. Current flowing is 1 ampere. Okay, first reading taken. Second reading, what did we do? We erased this, and then we basically went ahead and connected it here. Now, once you connect here, what would happen? Current will go this way, 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 and then go this way. And then again it will pass through both of these batteries. Okay. Now, what happened here is, both of these batteries together are applying a potential difference of 4 volt. So, we write here 4 volt. Now, it was seen the moment you were doing this from 2 volt to 4 volt, the current which was flowing here increased from 1 ampere to 2 ampere. This increased to 2 ampere. So, see, current is increasing, voltage is increasing here, current is also increasing. Now, let us take another reading just to reconfirm. So, what do? We remove this particular connection from here, and we are going to put another connection from here. Now, see, how many batteries have we connected right now? 3 batteries. We have connected 3 batteries out here. Battery number 1, 2 volt, battery number 2, 2 volt, battery number 3, 6 volt. So, here the reading of V is 6 volts, and the reading has gone from 2 to 4 to 6, which is 3 times. The current will also go from 1 to 2 to 3, which is 3 ampere. Are we clear? Are we clear here? Right? So, this is the setup of Ohm's law. It is a very important question. You need to remember this particular diagram. Yes, sir, you have to remember it and you have to practice it. no excuse, you have to practice it. What is there? Battery, ammeter, voltmeter, current and the switch. Remember, this is very, very important. You have to put this switch out there. And the switch, you have to put a dot in between to show that it is connected. If you don't put a dot, it is not connected, marks will be cut. Okay. All right, let us move ahead to the next part of it. Okay. Okay. Next thing that we are talking here is combination of resistance. You remember I talked about something voltage in parallel or something. Okay. Now let us understand. This is a very, very, very important concept, and I promise you, if you pay attention to this concept, if you are paying attention to this concept, you will never, ever, ever in your life make any mistake in the questions in resistance. Remember this. Okay. So first thing that we talk here is that we have got in series. First combination is series. So what is series? You have web series. How many of you watch web series? Series is one after the another. The episodes come 1 and then 2 and then 3 and then 4. I mean, you watch them one by one. So that is series. Similarly, the resistances are being put in series. One resistance, second resistance and third resistance. One after another and another. Okay. This is called series. Now, whenever you are putting resistance, remember there are two brothers and sisters of resistance, which is voltage and current. What would happen to the current and voltage? Now, if these have been put and we are imagining that this is a circuit, current will come from here. Current comes from here, passes through this resistance R1, passes to another resistance R2. Same current is passing, Same current is passing. Same current is passing. Through all these resistances, same current is passing. So what would happen? If I say the total current that is being passed from here is constant. Each of the resistance have got constant current. So I would say current here is, one second. Sorry, I started using blue. All white. This is same. The current in resistance which is connected in series is same. Now current is same. Let us have this another, our dear equation, V is equal to I into R. The current is same and each resistance is different. So the potential difference across each one of them would be what? So the potential difference across each would be V1 is equal to I into R1. Correct? Here V2 would be I into R2. V3 would be I into R3. You see, I is same, but because the resistances are very, very different here, each one of them have got a different potential difference. So voltage here is different. Remember this, in series current is the same, voltage is different. So now what is the total resistance of this particular figure? I mean, we don't call it total resistance, we call it equivalent resistance. Total is a simple sum, always simple sum doesn't apply. Here the total resistance is the equivalent resistance or resistance equivalent. Resistance equivalent in case of series is R1 here, R2 plus R3. Right, AD sir, it is so simple. It is so simple, AD sir, that R1 plus R2 plus R3. So the equivalent resistance is R1, R2 and R3 is the addition or the summation of all three of resistance if they are connected in series. Now let's see what happens in parallel. Now in parallel something, how do you say? Oh, the closest thing parallel is parallel lines. You've seen parallel lines, you've drawn parallel lines in maths. What is the definition of parallel lines? Okay, I'm not teaching maths, I'm teaching physics. But these three look like parallel lines. Okay, here at least they look like parallel lines, so it is parallel. Now all of these resistances are connected to 1 and 2 same points. Let us say this is X and this is Y. All of three of them connected to X and Y. Now let us see, this X and Y is connected to a battery or a cell, and this cell has got a consistent potential difference of V. Now see, this is R1 connected to X, connected to Y. R2 connected X, connected Y. R3 connected X, connected Y. So you are seeing all of these three resistances are connected to the same point, which is connected to this cell or battery. So all three of them will have same potential difference across them. Are we getting it? All three of them will have same potential difference across it. So V here in this particular thing would be same. Now V is same, okay? I is coming from here. Let me use another color pen here, right? I is coming from here. Till here it was I. After this, I was like, now where should I go? There are three paths for I to go. There are three paths for I to go. And I may choose to go different amount in different path depending upon the resistors. But for this particular explanation, let us understand that this I will go here as I1, I2, I3. This will go as I1, I2 and I3. And what would happen here? They will come out here as I1, I2 and I3. And total again current I will flow from here. Are you getting it? So in the case of parallel, I is different. In the case of parallel, I is different. Now, beyond just by looking, how do you find out if the resistances are in parallel or are in series? I'll give you one very, very simple way to recognize. You follow the current. It is said when you are lost in a wood and you find a river, you follow the current. Here also, if you are lost in resistance wood, you follow the current. Now here you see that in this, same current is passing from R1, R2 and R3. If the same current is passing from all the resistors, then they are in series. Simple, basic. If the follow the current, if the same current passes through the resistors, they are in series. If the current is distributed like this, they are in parallel. Are we clear about this? Okay. Now, equivalent resistance of parallel. Let us see that. Here the things change. What happens is here R equivalent is equal to 1 by R equivalent is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Now remember, this is 1 by RE. 1 by equivalent resistance is 1 by RE is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Okay, this is not equal to 1 by R1 plus R2 plus R3. This is not, this is wrong. This is the real thing, and then you have to take out the LCM and find the answer. Whatever answer would come, that would be 1 by RE. You need to make it a reciprocal of that. It will become RE. We will do a lot of questions for this and then we will be able to understand this. We are clear about this? Okay. So, remember, series and parallel. Same current, all resistance, series. Different current, different resistance, parallel. Okay. Let's move ahead now. Okay. So, one very important fact of the series and parallel, which usually comes into examination in one form or the other form, is like if the resistances are of the same value, which combination gives higher or lower equivalent resistance. Very, 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 very important. It comes in your exams. See this. Let us see if I have got 1 2 and 5. resistances R1 and R2, and same resistances if are connected in parallel, R1, R2, 2 and 5. Let us find out the equivalent resistance of these. Equivalent resistance of this R equivalent would be R1 plus R2, because this is in series. Why this is in series? Because if the current will come from here, same current will pass from here, same current will pass from here. R1 plus R2 is equal to 2 plus 5 is equal to 7 ohm. Put ohm also here, I'm sorry, right? Now let us see this particular arrangement where the values of resistance are the same. Here the current will go from I here, it will go here I1, here it will go I2. So these are in parallel. Okay. So here equivalent resistance is RE is equal to 1 upon R1 plus 1 upon R2. Right. 1 upon RE is equal to 1 upon 2 plus 1 upon 5. So what is the LCM? You take it out, LCM is 10. It is 5 plus 1 second, guys. So it is 5 plus 2 is equal to 7 upon 10. 7 upon 10 is equal to 1 upon RE. See that? 7 upon 10 is 1 upon RE. So what is RE? RE is equal to, you make it a reciprocal, 10 upon 7, which is equal to what? 1.4 something something something. 1.4 ohms approximately, right? Now see here the equivalent resistance was 7 ohms and here equivalent resistance is 1.4 ohms. So if the same combination of resistances are there, the resistance in parallel would be less than resistance in series. Remember this. Resistance in parallel, if the same value of resistance are put in, resistance in parallel is always lesser than resistance in series. Clear about this? Very important concept. It comes in your examination. Okay. Now we are going to go to the next. Now we have understood how the resistances are connected in series or in parallel. Okay. We are going to solve some questions and make sure we solve lots and lots of questions so that your all doubts are eliminated, erased, gone, bye-bye, tata. Okay, so let us see this question here. This question is asking find the equivalent resistance. Okay, find the equivalent resistance. Now here we see, before we find equivalent resistance, we need to find out whether the resistance are in series or in parallel. Okay, let us see. Here the current is going and here the current has changed, I1 and I2. So the current has split. Both the resistors are receiving different current. That means this is in parallel. It looks also in parallel, but when we go further, we'll find little difficult things. Okay. So here, very simple. Resistance equivalent कैसे निकालेंगे? How would we find out? R1 upon RE is equal to 1 upon R1 plus 1 upon R2, which is equal to 1 upon 4 plus 1 upon 8, which is equal to 8 would be the LCM, 2 plus 1 upon 8, which is equal to 3 upon 8. Now this is 1 by RE. So RE would be 8 upon 3 ohms. Okay. Let's go to the second question. Here it says that current is going to come from here. It is splitting I1 here, I2 here, and then again it is becoming I and crossing through this. There are three resistors. See this carefully. This is first resistor, this is second resistor, and then this is the third resistor. Now we have understood that these two resistors are in parallel. So if these two resistors are in parallel, let's first find the equivalent resistance of these two resistors. How am I going to find out? Very simple. 1 by RE. So resistance equivalent I can find out is 1 by RE is equal to 1 by 2 plus 1 by 4. We take the LCM, then this is 2, then this is 1, and I have is 4. So this becomes 3 by 4. So RE becomes 4 by 3. So now the equivalent resistance of this is 4 by 3. Okay, now if we combine them, make them one resistor, so then this 6 ohm is basically into series with this resistor. See this? Is into series with this resistor. So next part would be we add this 6 ohm and this series resistor. So 4 by 3 plus 6 would be the answer. Calculate this answer. Okay, so we'll revise once again. 4 ohm and 8 ohm, both of them have been put into parallel. Why into parallel? Because currents are going different. So 1 by 4 plus 1 by 8. I take a LCM 8. Then 2 plus 1, 8, 3 by 8. 3 by 8 is 1 by RE. So RE is 8 by 3 ohm. Similarly here, if you have a look at it, there the current comes here, there are 2 resistors who are in parallel, and then one comes in series. So first you calculate the resistance equivalent of this, which is 1 by 2 plus 1 by 4, so which is 2 plus 1 upon 4, 3 by 4. 3 by 4 is 1 by RE, so RE becomes opposite, it becomes 4 by 3. Now these two resistors have been replaced by 4 by 3, and you have got 6 ohm in series, so you add 4 by 3 plus 6 is you'll get the answer here. Okay guys, all right, moving ahead. A very complicated question, and they have asked that find the equivalent resistance. CBSE 2021 the question was asked. So remember the resistance unit. What is that? Ohm. You see a resistance question, first say ohm, and now let us solve. Again the rule remains the same. Let's see, this is resistance 5 ohm. Okay, the current is flowing from 5 ohm, it reaches to a junction here, here it will go at I1, here it will go I2. Okay, then this I1 is going to pass through R2, I2 is going to pass through R3, and then both of them are going to meet, and again current I will pass through this 5 ohm. Now see, this 5 ohm and this 5 ohm, they are getting same current is being passed to them. From whatever direction the current has come, it is the same current. So both of these are into series. First remember that. Okay. Now here we have got two different currents flowing through two different resistors, so they are into parallel. So let us find the equivalent resistance. First we are going to find the equivalent resistance of this part. Okay. How am I going to find it? So R1 upon RE is equal to 1 upon 10 plus 1 upon 10. Easy peasy lemon squeezy. This is 2 upon 10, which is 1 upon 5. So the resistance of this is 1 upon 5. No, it is the reciprocal of 1 upon 5. So RE here would be 5 ohm. You thought I was making a mistake, Good, you caught me. So here for this entire unit I can replace it with a 5 ohm. So let me just take a different color. So this is RE of both of them, and then this becomes 5 ohm. Now it is become even more easy peasy lemon squeezy. How? Because you see that the resistor, this one and this one and this one, they are all in series. So the resistance equivalent would be 5 plus 5 plus 5 is equal to 15 ohms. Okay, important question, came in the boards, but you were able to solve it. See, now you are becoming a player. You are playing with voltage, current, resistance. Okay, yeah. If you are able to solve these questions, you surely are becoming a player. Oh, don't get any wrong ideas, Okay, now this is find equivalent resistance. Now remember one more thing. Whenever it is told that find equivalent resistance, before you jump into finding equivalent resistance, you need to think between which points. Between which points do I need to find equivalent resistance? Usually they are going to give this kind of, usually in exams, you are going to get this kind of, you know, indications that this is the point, these are the points. So basically between this point, say point A and point B. All right. Now let us see, again the rule is the same. The electricity, the current rule remains the same. The current, when goes from here, it will come to this junction and then it will divide into two parts. Let us say here it is I1 and let us say here it goes I2. Okay. Now this I1 is traveling. It crosses 4 ohm resistance, travel, crosses 6 ohm resistance, travel, reaches the point B. Now this I2 travels from 13 ohm, from 7 ohm reaches point B. So see, this resistor which is 4 ohm and this 6 ohm resistor are getting same current. So they are in series. 13 ohm and 7 ohm are getting same current. So they are also in series. So we add both of them. If I find equivalent resistance of this branch, it would be, say I say this is branch A. Okay. This branch is branch A and this branch is branch B. So RA would be equal to 4 plus 6, 10 ohms. RB would be equal to 13 plus 7. RB is equal to 13 plus 7, 20 ohms. Now both of them right now have become and taken a shape of a final parallel. See this? This entire block has got a current of 4 ohm plus 6 ohm, 10 ohms. And this entire has got 13 plus 7, 20 ohms. So now there is this 110 ohm here, you can say 110 ohm here, 120 ohm here, and this is a perfect parallel formation. So how do you find out the resistance? So 1 upon RE would be equal to 1 upon 10 plus 1 upon 20. So how do we calculate this? This would be 2 plus 1 upon 20, which is equal to 3 upon 20. Now this 3 upon 20 once again is 1 upon RE. So RE would be equal to 20 upon 3 ohms. Okay. So never get scared of these things. Use the basic rule, flow the current from somewhere and then see which all resistors are getting same current. They will be in series and you just need to add them to find out the resistance. Okay. Now the question which came in CBSE 2025. Find the equivalent resistance between A and B. See, I told you that. Find the equivalent resistance between A and B. So here you have got A, here you have got B. So current is going to start from A and it is going to exit from B or vice versa, whatever. So if the current I is coming here, one part of current will go here, one part of current will go here. Let us say here it is again I1, here it is I2. Now this I2 will pass through this 2 ohm, it will pass through this 2 ohm, it will pass through this 2 ohm and then it will come at this junction. This I1 will pass from this 2 ohm and come at this junction and here both of them will exit I. So if there are 3 resistors from which I2 is passing, see this, 1, 2, 3, then all these 3 resistors are in series. So if they are in series, what is the resistance equivalent here? RE would be equal to 2 plus 2 plus 2, which will be equal to 6 ohm, and this is again is 2 ohm. So now you see it looks kind of into parallel. This is 6 ohm, this is 2 ohms. Okay, so what would be the total resistance equivalent? If I say 1 upon RT would be equal to 1 upon 2 ohms, this one, plus 1 upon 6 ohms, this one. Let us take LCM. So 6, this is equal to 3, and this will be equal to 1, this will be equal to 6, that is equal to 4 upon 6, which is equal to 2 upon 3. Now this is 1 by RT. RT would be equal to 3 upon 2 ohms, right? So very important, between A and B. So whenever they say between A and B, pick a point and make the current flow from there. And see what all resistances the current, same current is passing. They all would be in series, and you calculate the equivalent resistance of it. Okay? All right. Now, taking another question here. Point to note, RP is RS. What is RP and what is RS? RP means resistance in parallel, and RS means resistance in series. It is saying RP, resistance in parallel, is always less than resistance in series. Let us check that. Here we have got 2 in series resistors. How do you know it is in series? Because if you flow a current from here, same current will flow from 8 ohms, same will flow from 12 ohms. So equivalent resistance of them would be 12. Okay, 12 ohms. Here I have got same resistances. Please see that. Same resistances are there, and they both are in parallel. How do I know they both are in parallel? Okay, Baba, current comes from here, half of it or whatever, I1 goes here and I2 goes here. So both of these resistors are getting different current, so they are in parallel. So what would be their resistance equivalent? 1 by R is equal to 1 by 8 plus 1 by 4. So this will have LCM as 8. This will give 2 plus 1 upon 8, which would be equal to 3 upon 8. Now 3 upon 8 again is 1 by R. So R would be equal to 8 upon 3. Now see, 12, which is the resistance in series, and this is 8 upon 3 ohm resistance in parallel. So very well established that resistance in parallel is less than resistance in series. You will learn more about this when we are going to talk about the home appliances. How are the home appliances placed in our homes? Parallel series, you will find the advantages out there. Okay, are you guys getting it? Are you guys getting it? डरने का नहीं, बिल्कुल नहीं डरने का, लड़ने का. We have to give the best fight, and I promise you, if you are going to give the best fight, you are going to be the best. Okay, you are going to be the best player. All right, yeah, best player. Let's go on. Find the maximum and minimum resistances using 4 resistors of 4 ohm each. It has come in 2020, 2023, 2025, will all probability may come next year. So what is it asking? It is asking you to find maximum and minimum resistances using 4 resistors of 4 ohms each. That means all the resistances are equal here as of now, which are being utilized. Let's draw the diagram. There are just 2 ways in which the we can have a connection, series and parallel. So let us see. Let us make it in series. 4, 1, 2, jig 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 jig. 4 ohm, 4 ohm, 4 ohm, 4 ohm. This is one. Let us see the next one. We put all in parallel. Jig 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 jig. Jig 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 jig. Say with me. Jig 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 jig. It is fun. Jig 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 jig. Okay. Now 4, 4, 4 and 4. As per the rule, we flow the current. Passes to the same. This is in series. So resistance equivalent is 4 plus 4 plus 4 plus 4, which is 16 ohms. So if all these are put into series, they will give the maximum resistance, which is 16 ohm. Let's have this. This is in parallel, because if you throw current here, each of the branches are going to get different current. Here it could be similar, but because they are all 4 are the resistance, but not equal to the original current which flows into them. Okay, so here 1 by R will be equal to 1 by 4 plus 1 by 4 plus 1 by 4 plus 1 by 4. Now I'm not going to go into LCM. This comes to be 4 upon 4. This makes to be 1. Now see, in parallel it is 1 ohm, in series it is 16 ohms. 16 ohms. So series, definitely resistance in series definitely is higher than resistance in parallel. If the same resistance are used here, it is proven here. Okay, let's go ahead. Next question. If 4 identical resistors of 8 ohm are first connected into series and then into parallel, equivalent resistance of series and parallel are RS and RP respectively. Find the ratio of RS and RP. Very simple question. We just did that. It was asked in CBSE 2023. So let us again go and become very, very methodical out here. Okay, so it says 4 identical resistors, identical resistance of 8 ohm connected into series. So we connect into series. Jig 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 jig. So this is 8 ohm, 8 ohm, ohm, 8 ohm, 8 ohm, 8 ohm. Okay, resistance equivalent in this would be 8 plus 8 plus 8 plus 8, which is 32 ohms. This is RE. Now we go into RS, sorry, this is RS, not RE. This is RS, resistance equivalent, resistance equivalent for series. Then we have this into parallel. Okay, you are saying jig 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 jig. Okay, jig 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 jig. Okay, okay, one more jig 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 jig. And this is 8 ohm, 8 ohm, 8 ohm, 8 ohm. Current coming from here, each one of them not getting the equivalent matra of the current that flows in. Okay, so 1 by RP would be equal to 1 by 8 plus 1 by 8 plus 1 by 8 plus 1 by 8, which will be equal to 4 by 8. 4 by 8, which is equal to 1 by 2. 1 by 2 is 1 by RP is 1 by 2. 1 by RP is 1 by 2. So RP would be equal to 2 ohms, reciprocal of it. Okay, now what is asking? Ratio of RS upon RP. So Baba, it is very, very simple. 32 ohms upon 2 ohms in ratio, this get cancelled, so it is 16. So the ratio of RS and RP is 16. Okay, simple question, little lengthy but methodical. Okay, this question's done. Let us go ahead. Okay, now a question which will actually test your brains, right? Beyond the formula, something very, very different. Let us see that. It says, how would you connect 3 resistors of 2 ohms and get equivalent resistance of 3 ohms? You have 3 resistance of 2 ohms and you need equivalent resistance of 3 ohms. Let us see. Let us see if I connect them into series, what would happen? 2 ohm, 2 ohm, 2 ohm. So if I connect them into series, this is one way of doing it. Okay, so 2, 2, 2. If I connect them, this will give you 6 ohms. So our 6 ohm is not 3 ohms. If I connect all of them into parallel, 3, 3, 3. So 1 by R is equal to 1 by 3 plus 1 by 3 plus 1 by 3. This would be equal to 3 by 3. If it is 3 by 3, it is still not 3 ohm. Okay. Arey yaar. Sorry, this is not 3 ohms. No, that is right. I made a mistake. मेरे को ऐसे देखने में प्रॉब्लम होती है. And I look at this like this. So I like 3 here, 2 here. Okay, now the question comes which is going to test your understanding of series and parallel, not just the formula application. But if you have understood this, this is easy peasy. Yes, lemon squeezy. Now see, how would you connect 3 resistors? First of all, it is 3 resistors of 2 ohm each. 3 resistors. Okay, so there are few ways that we have learned. First of the way is series. Let us put them into series. 1, 2, 3, 2 ohm, 2 ohm, 2 ohm. If I find resistance equivalent, this is 6 ohm. So Baba, 6 is not equal to 3. Now let us put them into parallel. 1, 2 here, third here. We are putting them into parallel, right? 2, 2, 2. So 1 by R is equal to 1 by 2 plus 1 by 2 plus 1 by 2, which is 3 by 2. Now this is 1 by R. I'll make it R is equal to 2 by 3 ohms, which is still not equal to 3 ohms. So there has to be some different combination that we have to find out. Okay, let us find out that different combination. So in this combination, we are going to try either I put 2 of them into parallel and see what happens. Okay, so I'm putting this into parallel. I have put 2 resistances into parallel and I have put third into here. Okay, you see this, I have put 2 into parallel. So this is 2 ohm, this is 2 ohm, then this is 2 ohm. Now since current is coming from here, it is going in different directions in these resistances and then combining here coming out as I. So if I find out the equivalent resistance of this, 1 by RE is equal to 1 by 2 plus 1 by 2, which is equal to 2 by 2, which is equal to 1 ohm. Okay, now if this entire setup is giving you 1 ohm, and then this setup becomes in series with this, so this basically becomes something like this: 1 ohm here and 2 ohm here. This 1 ohm is the equivalent resistance and 2 ohm is the given resistance. Now see, these have become in series, so 1 ohm plus 2 ohm, which is equal to 3 ohm. So the combination is that you will have 2 of the resistances in parallel and then the third one is going to go into the series of this 2. That's how we solve this question. Okay, got it guys? Okay, now let's go towards the next question. Okay, so this has come in 2020 and 2024. Okay, similar kind of question which says, how would you connect 3 resistors of 6 ohms and get an equivalent resistance of 9 ohms? You get the equivalent resistance of 9 ohms. So very simple, just by looking at it you can see if 3 resistors are in series, they will give you 18 ohms. Simple. They will give you 18 ohms. If 3 resistors are in series and they are of 6 ohms, they'll give you 18 ohms. See, resistance 1, resistance 2, resistance 3. 6 ohm, 6 ohm, 6 ohm. I'm not even going to put anything here. Writing directly 8 ohms. 18 ohms, sorry. If they are into parallel, then 6 ohm, 6 ohm, 6 ohm, 1 by 6 plus 1 by 6 plus 1 by 6, which is 3 by 6. I put it up reciprocal, it becomes here is 1 by 2 and reciprocal is 2 ohms. So if I put in purely series, it is 6 ohm. I put purely into parallel, it is 2 ohms. That means there has to be some different way of doing this. Let us see. So I'm going to put it here. I put 1 here, 1 here in parallel, and I put the third one in series. Okay, so here again the current goes, it moves here, since they are parallel. This is 6 ohm, this is 6 ohm, this is 6 ohm. Equivalent resistance of this particular thing would be 1 by 6 plus 1 by 6, which will be equal to 2 by 6, which will be equal to 1 by 3. So 1 by RE, this is 1 by RE. So RE would be equal to 3 ohms. Okay. Now this 3 ohm, the equivalent The equivalent resistance here is basically, here they have put it as 3 ohms. Now if you look carefully, both of these 3 ohm and 6 ohm, they come in series. This is 3 ohm, this is 6 ohm, and their equivalent resistance would be equal to 3 ohm plus 6 ohm, which will equal to 9 ohm, and this is the answer, equivalent resistance of 9 ohm. This is the answer. You got it, guys? This becomes the answer. Clear? Okay, so here we are going to, so let's do a question which has come in CBSE, and it is based upon what we just learned, RP and RS, which is resistance in parallel. Which one of the graph is correct? Let us see. This RP shows resistance in parallel, this RS shows resistance in series. Let us see the, if this is a graph, it has got a slope. Let us see which has got a higher angle here. Higher angle. This is one angle. And then I have, this is another angle. Say this is angle Y, and this red one is angle X. Here also we do. This is angle X and this is angle Y. In this case, we see angle Y, which is of resistance, is series, is greater than or less than, is lesser than angle X. So this is saying, which is angle RP. Here it is saying that the resistance in series is lesser than resistance in parallel. And what have we learned? Resistance in parallel is lesser. So this is incorrect. And here we see that angle X, which is the angle of resistance, is greater than angle Y, which is resistance in parallel. This is correct. This is absolutely correct. Okay. Remember, important question, slope is to be considered. Higher the slope, higher the resistance. Higher the resistance, higher the resistivity. Okay. Remember these things. All right. Now we go to the next topic here. Okay. So the next question which came again from the parallel and the series part was the advantage over parallel over series. It was in CBSE 2024. Now in your house, how are the appliances connected to each other? Is that in series? Is that in parallel? We need to understand that. What are the advantages of series and parallel? So first we are going to draw it. Okay, we are going to draw. So this is series and this is parallel. Now say you have got one AC, one TV and one fridge. AC, TV and fridge. I here also say A, AC, T, TV, F, fridge. A scenario. Let us assume that all your appliances are connected in series. Now, if all appliances are connected in series, the current will flow from here, same current will go to here, same current will go here. Okay? No way of regulating how much current goes where. Same current is going to flow. Because of something, some problem, your AC got broken and no longer it is able to, get the current through it. Now, if this happens, then your TV and your fridge both will stop working. If this happens, then your TV and your fridge both will stop working. And what would happen here? If the current is going from this place, since it is in parallel, here it will be IAC, IT, IF. So if AC does not work, it does not affect the TV and the fridge, and all the appliances keep on working. So if the appliances are connected in parallel, it is a distinct advantage because all of these are independent of each other. So the first point, advantage of parallel over series, is that all devices are independent of each other. Clear? Logical? Makes sense? Cool. Now let us see next point. Like we said, here each of the device is giving fixed current I. Each of the device, irrespective of the nature of the device, irrespective of the requirement, they are getting, each is getting current I. So like you have your brothers and sisters, and each one of them has got a different appetite, but each one of them is being given a fixed amount of food. Somebody will stay hungry and somebody will be overfeeding himself or herself, correct? Similarly, if the current is the same going into each of the particular devices, there are bound to be problems because different current goes into different devices, or same current going to different devices may cause some devices to malfunction. We'll read about that when we are going to talk about the electrical appliances. Now, if the situation is that they are in parallel, then each of the device is going to get, okay, let me just rub this and make it again. If they are connected in parallel, now see, if each one of them are connected into parallel, each one of them are going to get different currents because they are different devices, different resistances, and it can be regulated which device gets which current. So the second point is that each device gets the required current. Each device needs. So all your brothers and sisters, if are being given the same amount of food, someone will always be hungry, and someone will always have his stomach upset. So each one of you or the brothers and sisters would require different amount of nutrition. So some of them may fall ill because of this. Similarly, if each one of the devices are getting the requisite amount of current, they will function properly. If each one of them are getting same amount of current, they will function differently. Improperly. Now, next is, it reduces the equivalent resistance. We have just read that the resistance in parallel is always lesser than resistance in series. So the overall resistance of the entire wiring in the house would be lower if all the appliances are connected in parallel, which will result in better energy efficiency. Okay, all right. Let us move ahead to the next topic. Remember all this, but don't worry. Till now, you guys have covered a lot of things, but at the end, I'm going to summarize everything for you. Okay, we are going to put a sheet which is going to talk about the definitions, about the SI units and everything below. But before that, go through the entire chapter. Okay, now let's go ahead. Okay, so the next thing that we are going to talk about is the components of electric circuit, and they always come in examination some way or the other. Please remember that. Okay, the first thing is electric cell that we have read about. First thing that we see is electric cell that we have read about. It is noted by this. This is positive, this is negative. You add too many cells, it becomes a battery. Again, the SI unit is volt, Next comes is the switch. You remember that switch? If the switch has got this dot into it, the switch is closed. That means the current can be flowing through the switch. If it is open, the switch is not on. This is called wire joint, and wire crossing. You draw a wire and you make like this. It becomes wire without crossing each other. Then you've got electric bulb. In this electric bulb, you've got this heart-shaped thing inside, or a proper bulb could be given, which would look like just like a bulb. Okay, let's go ahead to the next one. The next one is resistor. We have seen this resistor. So what is resistance? Please answer, what is resistance? Resistance is the property to oppose the flow of current. And what is resistivity? it is the property of the material. Okay, we'll keep on revising this. Okay, then you've got rheostat. Now in rheostat you see this is resistance and then one arrow is given. It means that by shifting the arrow you can change the resistance. How? You remember resistance is directly proportional to length. If you reduce the length, the resistance will increase. If you increase the length, if you reduce the length, resistance will decrease. If you increase the length, resistance will increase. With the, remember the flow of the direction of the current. Ammeter is basically written as A. It is required, it is used to measure the current, and it is ampere, this is ohms. And voltmeter, our dear voltmeter, which is required to utilize to measure the voltage, and the SI unit is volt. Okay, so these are the electric circuit. A question came which says, what do below symbols represent in an electric circuit? Write one function of each. Very, very simple. This is what? This is resistance. This is rheostat. Resistance is basically utilized to control the flow of current. This is rheostat, which is again utilized to manage the amount of resistance. This is ammeter. Ammeter is used to measure the current, and this is voltmeter. Voltmeter is used to measure the voltage. Okay. All right. Moving ahead. Okay, so now here we are going to talk about some really complicated questions which are going to utilize both IVR, all three of them, and circuit diagrams and the voltage and the current. So just be with me. With this one single question we are going to clear whatever confusions you have got. We are going to clear all of them. Read this question with me and we are going to go together. This says, draw a schematic diagram of a circuit consisting of a battery of 4 1.5 cells. Please remember what it has said. It has said 4 1.5 cells. A 5 ohm resistor, a 10 ohm resistor, and a 15 ohm resistor, and a plug key. All connected in series. Okay, let us first draw the diagram. It is saying 4 1.5 volt. Now I am going to draw this battery. So this is battery 1, 4 volt, battery 2, 4 volt, battery 3, 4 volt, battery 4, 4 volt. These are 4 batteries which 1.5 volt. दिखता नहीं है क्वेश्चन ऊपर से, मैं ऐसे लेना पड़ेगा. I think what? Tell ना. What?
थोड़ा इधर कर सकते हैं questions.
I stand here and read them. Okay, चलो. That's a good idea. I mean, I forget what is written, then I draw something different.
Previously, we used to align questions only towards the right.
Why didn't we do this time?
Some questions are too huge now, so.
Arey, reduce the font, pa. Again. 8, 10. That's what I leave by. Anyways, somebody has called me. Who has called me? Okay, now we come to a question which is, utilizing whatever we have learned up till now. It is going to utilize that. So this question came in CBSE 2024. We are going to read that question very carefully and then we are going to go along with the question and solve it. It says first part is, draw a schematic diagram of a circuit consisting of a battery of 4 1.5 volt cells, 5 ohm resistor, 10 ohm resistor, 15 ohm resistor, and a plug key, all connected in series. Let's first draw this. The question first is 4 cells with 1.5 volt. 1 cell, 2 cell, 3 cell, 4 cell. Okay. We connect them. Okay. 1.5 volt, 1.5 volt, 1.5, right volt, baba, they will deduct marks, and 1.5 volts. Then it says 5, 10, 15 ohm resistor. Okay, I'm going to put 5, 10 and 15 ohm resistor. 5, 10 and 15 ohm resistors, which is all in series, right? And a plug key. You remember that plug key? And a plug key. So this is the schematic diagram. I mean, please, you use the scale, etc. I've just made it this way. Okay, don't try and make it this way. The marks to be deducted. Make it cleaner. Okay. Now find electric current passing through the circuit. It is asking for electric current passing through the circuit. So we have this formula of V is equal to I into R. I need to find I. What will be the R? If I have here 5 volt, 5 ohms, 10 ohms and 15 ohms. Resistance 1, resistance 2, resistance 3, 5 ohm, 10 ohms and 15 ohms. We need to find out the current. Let us find out the resistance equivalent. They are in series because current will come from here. Same current is going to pass through all three of them. Okay. So we have to find resistance equivalent, which will be equal to 5 plus 10 plus 15. How much would this be? This would be 30 ohms. So we have R is 30 ohms. We have battery is 1.5, 1.5, 1.5, 1.5. So you remember when we started, if you need to find the complete voltage of the cell of the battery, which has got different cells, it would be adding. So V would be 1.5 plus 1.5 plus 1.5 plus 1.5, which is 36 volts. Now let us put these values here. 6 volt is equal to I into 30 ohms. So I is equal to 6 upon 30, which is equal to 1 upon 5, which is equal to 0.2 ampere. So I would be equal to 0.2 amperes. Okay. The electric current passing through the circuit, we have found out I is equal to 0.10 ampere. Now find the potential difference across 10 ohm resistance. Across 10 ohm resistance, it is asking for this potential difference. Remember, potential difference is always between 2 points. So point number 1 here and point number 2 here. How do you find potential difference? V is equal to I into R. So here V would be equal to I. How much I? 0.2. It is going through all. It is going through all. And 0.2 ampere into what is the R? 10. So it would be 0.2 into 10, which would be equal to 2 volt. This would be equal to 2 volt, and the question is solved. Simple question. Complication la. There is no complication at all. You first draw this diagram and remember potential difference between 2 points. Let us move ahead. So the next thing that we are going to study is the power. I've got the power. Okay, but this is electric power, not that He-Man power. Now how do you define power? Power is defined as rate at which electric energy is consumed. Rate at which electric energy is consumed is called power. We'll talk about that little more, but understand the formula for power is P is equal to V into IE, where V is the voltage and I is the current. Okay, and the SI unit of power is watt, V is volt. Please keep on revising with me. I is, I will not tell you, please write that into the comments. Okay, write it. I is ampere. Okay. Now let us take this particular P and find out the power that we have to calculate. Now once you have to calculate the electric power, one thing that you have to remember is identify the resistor, the component, the unit across which power you have to calculate. So let us see if this is we have to calculate power like in potential difference. In order to calculate potential difference, you will ask what are those 2 points. In order to calculate power, you are going to ask which component. So this is the component. Say this is resistance R. In this resistance R, you would have volt, which is voltage across it, and you would have a current which is flowing. Okay, and our which formula, which brings lot of peace, lot of calm, which law is that? Ohm's law. Okay, so as per Ohm's law, V is equal to I into R. Okay, now see, if I have to calculate power in this particular component or resistance, first formula is P is equal to VI. Okay, now suppose I do not know V, this V is not known here. So as per V is equal to I into R, I will substitute I into R in place of V, then P is equal to I square R. P is equal to I square R. I square R. I square R. You have substituted I into R in place of this P. Now, if I do not have I, if I is not known, then I will know V and R, and I will substitute P is equal to, instead of V, V is there, instead of I'll write V upon R, and this will become V square by R. Please remember this. There are three formulas for calculating power. You have to remember this, and whenever it is said calculate power, across which component, the first question should come to your mind is across which component. Okay, it's important. So SI unit of power is watt. Lag gayi. No. Watt. Potential difference is volt and current is ampere. And with this, let us solve a question which has come in CBSE 2025 and 2024. So define electric power. Rate at which electric energy is consumed is electric power. Express it in terms of potential difference V and resistance R. It's right here. I mean, you can, if it's just one marker or two marker, you can just write this only. If it's more, then you say power is equal to V into I, V is equal to I into R, substituting the value of I, then you can derive the entire thing and write it across. Okay? Right. So this is about electric power. Let us go ahead. Okay, so now we have understood about the power, how power is calculated, what is the formula, and let us now start solving some numericals of power. Okay, so it says, this question came in CBSE 2024, and it says, in given circuit, calculate the power consumed in watts in the resistor of 2 ohms. The important part to see here is 2 ohms. It is not asking anywhere else in this particular circuit. So now let's first of all write the formula of power. The formula of power is P is equal to V into I. Now first thing that we need to find out is what is the I, current going into this particular resistor of 2 ohms. How do you find the current? Our old formula, V is equal to I into R. Now the current is going to flow into the entire circuit, so we need to find out the entire circuit's equivalent resistance first. So RE, in this case, what would be the RE? This is in series, you see, the current flows and the same current goes in both the resistors. So RE would be 1 plus 2, which is equal to 3 ohms. Equivalent resistance is 3 ohms. So by applying this formula, V is equal to IR, we find out what is the I. I is equal to V upon R. What is V? V given is 6 volts. So we have 6. What is R? R given is 3 volts, which is 3. So I comes out to be 2 ampere. Okay. Now we know the formula of power is V square into R, because this resistance is included. So, or power's formula is I square into R or V square by R. So here we put the formula of P is equal to I square into R. Right? What is the I here? We have calculated it is 2 ampere. So I square, not 1 square, I square. So 2 square into R, which is 2, which is 8 watts. All right. So the answer is 8 watts. Now see, something very important to note is this particular resistance was considered. This appliance, this electrical unit was considered. If you would have calculated adding these two, the power would have come for both these circuits. When coming in terms of calculating power, always find out which resistor circuit equivalent, which resistor or circuit it is being talked about. Okay, let's go ahead to the next. Okay, let's go to the next question. This question was asked in CBSE term 2021. Very important question. Let us read that. An electric heater rated 1100 watt operates at 220 volt. Now understand, whenever rating is given or rating is asked, you will need to find out two things. One is the power, next is the voltage. It is asking calculates its resistance and the current drawn by it. Okay, let's first note down whatever is given. What is given here? We have P is equal to 1100 watt and V is equal to 220 volt. What is our dear formula? Our dear formula is P is equal to V into I. What is being asked? First thing being asked is the resistance. And second thing that they have asked is the current. Okay. So now utilizing this formula, I, which is current, is equal to P upon V. What is P here? P is given 1100 watt. What is V here? 220 volt. Okay. Now, very simple. You just cancel this and this would come out to be 5 ampere. So the current that you have, current comes out as 5 ampere. If current is given, we have another our dear formula. V is equal to I into R. Remember that? I hope you haven't forgotten that, right? So R would be equal to V upon I. What is V given? V given is 220. What is the I here? I is 5. So what would be the answer here? 5 4s are 20 or 5 4s are 20. This would give you 44 ohm. The resistance is 44 ohm. All right. Simple questions. You have to just understand that power formula is VI. Now you are utilizing all the formulas together, and V is equal to IR. Let us go ahead to the next question. Now, very interesting question. It was asked in 2025, so do not get intimidated by this. Just read it. Read it very, very carefully and with patience. Consider two lamps, A and B, of rating 50 watt and 220 volt. Rating, two things, watt and volt. 220 and the next one is 25 watt and 220 volt again. So find the ratio of the resistances of lamp A and lamp B. Now let us just divide this into two parts. This is lamp 1, lamp 2. We'll calculate the ratio here. Let us first go ahead and find out what is the formula of power, and before that what all is given. So in A you have been given that the power P is equal to 50 watt and V is equal to 220 volt. Okay. In B, this is A. Let's consider this as A. And in B, it is given that P is equal to 25 watt and V is equal to 220 volt. What was the formula? We remember that, which shows the relationship between P and V and R. Forgot? Okay, let's revise it. So the formula that we basically would use, the basic formula that we are going to use is P is equal to V into I. Now what is missing here? I is missing. So we are going to put, instead of I, V is equal to IR. So we will substitute this I by V by R. So what would happen? P would be equal to V square upon R. P would be equal to V square upon R. Therefore, RA, which is the resistance of this bulb, would be equal to V square, which is for A, upon PA. Okay. Similarly, here also we will have P is equal to V square upon R. RB, which is resistance of this particular bulb, would be equal to VB square upon PB. Now, do not rush into putting the values. First, find out at the formula level and try to simplify at the basic formula level. So, RA upon RB is required to be put in. Let us put here RA upon RB. Okay. What is RA? RA is V square by PA, which is 220 square upon what is PA? PA given is 50 watt upon 50. Right? RB. What is RB? VB square upon PB. What is VB? 220 volt. 220 volt square upon PB. What is PB? PB is 25. Now, this and this would get cancelled because they are same. We would have 25 upon 50. RA upon RB would be 25 upon 50, which would be 1 upon 2. So, the ratio would be 1 is to 2. Okay. Don't get scared with these questions at all. Just look at them carefully and then you can solve them. Now, let us go to the next question. It says an electric iron consumes energy at rate of 880 watt when it is heating at the maximum rate and 330 watt when it is heating at the minimum rate. Don't get confused. Maximum, minimum, there are two cases given. Like in previous question we had lamp A, lamp B. There are two cases. Here also two cases are given. It says if the source voltage is 220. Now see, here again the source voltage 220 is constant. Calculate the current and resistance in each case. Okay, so I'm going to solve one of them and you are going to solve the other and put that into the comments. What answer do you get? Okay, first let us see what all is given here. Electric iron consumes energy 880 watt heating at maximum rate. So if it is maximum rate, it says the power is equal to 880 watts. Voltage is constant in both. V is equal to 220 volt. What is it asking? It is asking you to calculate current and resistance. Okay, very easy. P is equal to V into I. Therefore, I would be equal to P upon V. What is P here? P here is 880 watts. What is V here? V here is 220 volts. So this gets cancelled. What would you get? You will get 4. So I is equal to 4 amperes. Clear? Simple. Now the second thing you have to calculate is the resistance. So how do you go to resistance? V is equal to I into R. So R would be equal to V upon I. What is V here? V here is 220. So 220 upon I. What is I? 4. So this comes out to be calculated. 4 5s are 20, 4 5s are 20, 55 ohms. Okay, now you need to calculate this minimum part of it. Exactly same process, exactly same procedure. Calculate the minimum part of it. Okay, All right, now here we complete this very, very important numerical which came in CBSE 2023. Now we are going to go ahead. Okay, all right. Now are you understanding and getting that how are you going to become the player of electricity? Hope you are playing with it right now using V is equal to IR, P is equal to V into I, V is equal to IR. Like I said, you'll find, don't remember I is equal to Q by T, don't remember V is equal to work done upon charge. Yes, don't forget that. Series, parallel, slowly you are getting mastery of it. Second question, the next question is, okay, just read it. Do I need to do this question? It says 2 LED bulbs. Let's say 2 LED bulbs. Bulb number 1 and bulb number 2 of 10 watt and 5 watt. 10 watt and 5 watt. Are connected in series. If the current flowing through 5 watt is 0.005 ampere, the current flowing through in 10 watt bulb is, they are connected in series, and we know the answer here would be exactly. They are in series, so current would be same. So if this is 10 watt, it says in 5 watt, there is current of 0.005 ampere flowing, and they are in series. Where is this current from? It is current coming from here, from this particular 10 watt. So the answer would be same current flows in both of them. This is going to be the answer. Okay? No, it might look complicated, but just remember the law which basically talks about both voltage and current. What is that? Ohm's law. Calm down your mind and solve the questions. Okay? Okay, I'll just take a water break for a moment. Now, next thing that we are going to study is electrical energy. Till now we had studied electrical power. Now we are going to study electrical energy. So in common terms, if you are applying power somewhere, your energy is getting consumed. If you apply power somewhere, your energy will get consumed. Similarly, energy and power are two different things here, and electrical energy is power supplied by a cell. Just remember that. Electrical energy is power supplied by the cell, which is defined as E, which is energy, is equal to P into T. Okay? The SI unit of E, which is energy, where SI unit of energy is and work is joules. But here we write it is kilowatt hour. How did this come? This power is in watt. You can convert watt into kilowatt, just divided by 100. And this time T is to be considered into hours. So this is to be considered into kilowatt, and this is to be considered into hour. So energy is equal to P into T, where P is the power and T is the time in hour. And P can be written as V into I. P can be written as V into I. We just read that. So energy can be is equal to VIT. Voltage, current and time. Okay. So now SI unit of energy, like we talked about, is in joules. Here we are having it. Here we are having it into kilowatt hour. So 1 kilowatt hour is equal to 3.6 into 10 to the power 6 joule. Just remember it. Okay. 1 kilowatt hour is equal to 3.6 into 10 power 6 joules. So if the question comes and you are able, and it is asking you the to give the energy into joules, so the question could be how many joules of energy are being utilized. You will calculate that in P into T, which is kilowatt hour. So how many joules would be the conversion unit of 1 kilowatt hour is 3.6 into 10 power 6 joules. Clear about this? Okay, remember this. Let's move on to the next. Okay, now you've understood about electrical energy, which is equal to power into time. So what is electrical energy? The amount of power spent in a fixed amount of time constitutes electrical energy, and the unit of electrical energy is kilowatt hour. Now let us solve some questions of that. It says for a heater rated means power as well as voltage. So for heater rated 4 kilowatt and 220 volt, calculate the following. Okay, let's calculate. It says energy consumed in 2 hours. Energy. So what is the formula for energy? We just read that. Formula for energy is E is equal to P into T. Now what all is given here? I am given P. P is equal to 4 kilowatt. I have been given 2 hours. T is equal to 2 hours. Now, isn't this easy peasy lemon squeezy? You have got P, you have got T, you need to calculate E. Let us apply in this formula. So here E would be equal to 4 into 2, which would be equal to 8 kilowatt hour. Clear? Simple, very, very simple, easy peasy, lemon squeezy. Let's go ahead. Now it says if 1 kilowatt is priced at 4.50. Now what is this 1 kilowatt pricing? Now what happens is you would have seen electrical meter at your homes. So what does that meter measures? That meter measures how much electrical energy is being consumed in your house. Right? If you go and look it very, very carefully, you will find there are readings happening, right? And in those readings, what it is measuring is how many units of electrical energy is being consumed. So understand, 1 unit of electrical energy is equal to 1 kilowatt hour as far as electric meters are concerned, right? Remember this, 1 unit is equal to 1 kilowatt hour. Okay, now with that, let's solve this question. If 1 kilowatt hour is priced at 4.50, then the cost of energy consumed, how much energy, how many units? In this case, we see there are 8 units. So 8. What is the rate? Rate that is given is 4.50 rupees. Mind it, it is little expensive than 4.50 rupees. Don't consider this. It is just a question. Actually, you need to go and find out what is the cost of per unit cost of your electricity. Okay. So what would you do? You will simply multiply 8 into 4.5. This is how much? This is 36 rupees. This is 36 rupees. 8 5s are 40. Then you get 4. 8 4s are 32. 32 36. So here the answer would be 1 kilowatt price at about 4.5. The cost of energy consumed is 36 rupees. Okay. So in case if 8 kilowatt energy is consumed and the rate per unit is 4.5, your electricity bill would be 36 rupees. It rarely comes, so if you go and ask your parents, they'll actually tell you how much electricity bill comes in. Okay, all right. Let us see the next, a very methodical question, very important question, came in CBSE 2025, comes at a high mark. So this question we are going to solve step by step, and with this we are going to complete anything and everything as far as electric power is concerned. Okay, all formulas would be used here. Let us see that. Okay, now this says the rated voltage, rated means power and voltage. So the rated voltage of an air conditioner is 220 volt. This air conditioner consumes 22 units of electric energy. What is electrical energy? Electric energy is power into time. Remember that. In 10 hours. Calculate something. Let us write down what all we have got. It says the rate of rated voltage air conditioner is 220 volts. So what is V? V given here is 220 volt. Okay. It consumes 22 units of electrical energy. So E given is 22. 22 kilowatt hour. E given is 22 kilowatt hour. How much time? T given is 10 hours. Okay? This thing is given. It says find the power rating of air conditioner. So we have learnt about this formula that E is equal to P into T. Okay? So P would be equal to E upon T, which is, what is E here? E is 22 kilowatt. 22 upon time is 10. So this is equal to 2.2 kilowatt hour. Sorry, it is kilowatt, not kilowatt hour. It is only kilowatt. 1 second. Oops. Sorry guys, this keeps on happening. Sometimes it happens. Where is it? Where's the question? Yeah, here's the question. Okay, so I'm going to erase this. It's not kilowatt hour, it is only kilowatt. Okay. So kilowatt, but the unit of power is in watt. It is not in kilowatt. So I convert this into watt, which will be 2.2 into 1000, which is 2200 watt. So the power rating of air conditioner 2200 watt at 220 volt. Okay, first question. Second is asking current drawn by the air conditioner. Now current, we have heard about this power formula. P is equal to V into I. So what would be I? I would be equal to P upon V. What is V here? V has been given as 220. Power is 2200, which will be equal to 2200 upon 220. This and this get cancelled and this is 10. So I is equal to 10 ampere here. Okay. When I is equal to 10 ampere, and the second question says current drawn by the air conditioner is 10 ampere. Okay. Third question, resistance of the air conditioner. Okay. We know another formula, which is V is equal to I into R. This is which law? This is which law? This is no law. It is not Ohm's law. Ohm's law is V is directly proportional to I. This is the representation. Calm mind. We are using another formula here. So here R would be equal to V upon I. What is V here? We have V as 220 volts, 220 volts. What is I here? I we have calculated as 10 ampere, which is 10 ampere. So what would be the resistance? Resistance would be 22 ohms. Now see, in this particular questions, we have utilized quite a few formulas. E is equal to P into T. Here it is P is equal to V into I, and here it is V is equal to IR. Quite a few formulas have been utilized into this. So you would have such questions where multiple formulas would be applied. Just go one by one. Don't jump into it. Don't get scared of it. Okay. So this is one of the good questions of CBSE which was asked in 2025. Okay. Now let's go ahead. Now next thing that we are going to talk about is heating effects of electric current. You would be facing, utilizing, using heating effects of current every single day of your life. Okay. You plug your phone for charging, it's get hot. You get up in the morning, switch on the geyser, go for a bath. The geyser makes the water hot, right? The toaster, wherein you are toasting the bread, utilizes electricity, makes it hot. The iron, the press, uses electricity, gets hot. So how does this electricity thing is making things to become hotter? Okay. So this all happens because of the resistance. High resistance, high blockage, you are pushing it through and more heat is generated, right? More heat is generated out there. So when an electric current passes through a conductor or an electric device, the conductor becomes hot after some time and produces heat. Becomes hot after some time. So that means here the time is coming. Winter is coming. Time is coming. Here the time is coming. And this effect is called heating effect of electric current. Right? So this heating effect of electric current is being expressed via Joule's law of heating, where the Joule's law of heating says the heat produced is directly proportional to I square. Heat produced is directly proportional to R, and heat produced is directly proportional to the time for which the current is flowing. Okay? So all these three things become very, very important, and the formula from this for heat comes out is H is equal to I square R into T. H is equal to I square R into T. So let us see if this is a conductor and we have current flowing here. Okay? The current is flowing. This is R, and for T time. If it is being asked, calculate the amount of heat generated if the current I flows through R for T time. How would we do? Simple formula, H is equal to I square R into T. Remember, the heat is measured in joules. The heat is measured in joules. So revising this once again, when an electric current passes through a conductor and electric device, the conductor becomes hot after some time and produces heat. After some time is very, very important. This is called heating effect of electric current. It is represented via Joule's law like H is directly proportional to I square, H is directly proportional to R, and H is directly proportional to T. So H is equal to I square RT. Okay. Now, same question, theory-based question was asked in CBSE 23 and 24, which said, what is heating effect of electric current? Find an expression for the amount of heat produced when a current passes through a resistor for some time. Remember this some time, they'll always put as some time because time is important. So what is electric heating effect of current? This is heating effect of current. And where you have the find expression for the amount of heat produced using resistance for some time. This is the formula that you are going to write. Okay. Very important question. It has come again. We will learn about this little more in further classes, but for answering the questions till now, as of now, this is good enough. Okay. Let's move ahead. Okay. So the heat part of is over. Most of the heat is over, right? Last part of the chapter. So let's see this question, which says a 5 ohm resistor is connected across a battery of 6 volts. What all is given? R and V. And calculate the energy that dissipates heat in 10 seconds. Calculate the energy. Let us see what all is given. R is equal to 5 ohms. V is equal to 6 volts. And T is equal to 10 seconds. Okay. So how do we calculate the heat? The heat is calculated H is equal to I square R into T. That's what the formula of H. Do we have I here? No, we do not have I here, but not to be afraid of it. Do I have V and R? Yes, I have. So the formula is V is equal to I into R. I would be equal to V upon R. So let us replace it here. H is equal to V. What is V? V is 6. 6. What is R? 5. 6 upon 5 square into R again into 5 into T. What is the time? 10 seconds. So we have 36 upon 25 into 5 into 10. This 5 will go at 5. this 5 and this 10 will go in 2, and I will have 72 joules. The SI unit of energy is joules, 72 joules. It's a very simple question, but see, similar questions have been asked in 3 years. So it is important for you to remember the formulas. H is equal to I square into T. Don't worry about formulas. You patiently revise them. I've put a sheet also. You can download that sheet and paste it on the wall wherever you are studying. So first thing in the morning you get up and you revise the formulas. Okay, cool. Now we go ahead. Now this heating effect of current, like I said, we are utilizing it for every day in our life. We talked about the iron. Iron, when heats up, then you are able to press your clothes. Then oven, only when it heats up you are able to get those cakes. Then kettle, it heats up, you get water. And then geyser, something I remembered from geyser. Now this geyser basically is something which moms switch it on in the morning, and we do not go for a bath because saying it is too cold. Right now the cold is going to come. So don't worry, believe in Joule's law of heating, believe in electric effect of current, and fatavat go and take a bath. Okay. So now the question is, if you are required to make an appliance which will utilize electric effect of current, what kind of material should you use? One, the material should have very high resistivity. Why? Now if high resistivity is there, that means high resistance is there. If high resistance is there, H is equal to I square R into T, more heat will be produced. Are you getting it? So you are going to use a material which has got high resistivity. So if high resistance is there, more heat is going to be generated. And the problem with more heat is that it becomes very hot. Haha. The problem with more heat is it increases the temperature, and if temperature keeps on increasing, the things melt. So the next characteristic has to be that that material should have high resistivity and should have high melting point. What kind of materials have these things? Alloys have these things. So see, there was this question in CBSE 25. So high resistivity than metals, high melting points. Alloys have high resistivity than metals, and they have got higher melting points. These kind of materials you are going to use for the heating effect of the current to utilize it. So another very important question that comes is about electric bulb. So how does electric bulb work? How does electric bulb work? AD sir, you switch on and the light comes in. That's how the electric bulb works. No. Electric bulb has got something called tungsten. The filament, something that you see, we make electric bulb like this, and this heart-shaped thing. Hey, don't get any other ideas than heart-shaped things, okay? The heart shape is tungsten. It's a representation. So these heart-shaped things which are tungsten, they are called filament, and they have got very, very high resistivity and high melting point, because of which lot of heat is produced. Heat is produced, that is the main function, and then the light is produced. So most of the energy is utilized in producing heat than producing the light. So when the bulb has been on for some time, and you touch it, don't touch it, because it would be very, very hot. Okay, so electric bulb has got filament which is made of tungsten. It is heated and it emits light, and it has got a very, 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 very high melting point. Okay, got it guys? Heating effect of current. Okay, let's go towards the next heating effect of current also. Next is electric fuse or safety device. You must have heard about the expression ki fuse ud gaya. Many people when get angry, fuse ud gaya. No, this is not that fuse. Now this is a very, very nice safety device. Now imagine if you have got your nice wonderful PlayStation going on your TV. Okay, so say this is the TV and here we have got PlayStation. You are playing and all of a sudden, poof, the TV goes kaput. How did this happen? There could be various reasons, but one of the reasons could be that there was surge of current coming into that electric appliance which is TV. more than it could actually handle, more than it could have, it would have been made to handle. If that surge of electricity comes into the TV, it will get burnt. We say na, in Hindi we say TV fuk gaya. So there are certain circuits which have bombed off. It is because one of the reasons could be very, very high electric current coming into it. How do you safeguard this? This kind of things are being safeguarded. These kind of things are being safeguarded by fuse wire. Fuse wire. Okay. So what happens? In front of the appliance, you put something called fuse wire. It has got a wire into it. And the current first, before reaching to the appliance, passes through this wire. So property of this wire are little different. It has to allow that amount of current to pass. Okay. It has to allow the requisite amount of current to pass, and the moment current increases from the given capability or capacity, since the current will increase, heat will increase. I square, remember, the current goes I square, the heat goes I square RT, right? So current will increase, heat will increase. If the heat will increase, this guy or this fuse will quickly reach their melting point. These fuse will quickly reach their melting points, and this wire would melt, and the flow of current will stop, and your TV on which you are playing games will be safe. So what will you do? You will then replace this fuse wire or replace this fuse. The current will be established again, and the TV will start. So let's read a little about this. Electric fuse is used to prevent short circuit. Fuse has low melting point, so when high current passes through it, it melts due to heat produced, given by the Joule's law. Joule's law, I square RT, and stops the flow of current. Okay. Now think logically. How much current should a fuse wire let pass? If this appliance basically, if this appliance is asking for 15 ampere of current, should it let pass 13 ampere? Okay, pass. 12 ampere? Okay, pass. But 15 ampere? Okay, pass. 15.2 ampere? Okay, pass. 15.5 ampere? No. It could harm this appliance. So it will stop that current. How will it stop? It will sacrifice itself. It will melt and sacrifice itself so that this appliance remains safe. So you learn so much about sacrifice from the fuse. So the rating of fuse current is the maximum current that it can allow to pass. It could be 1 ampere, 2 ampere, 3, 4, 5, 10 ampere. And if high current flows more than the required, fuse wire gets heated and melts. Okay. So fuse wire is made of alloy, aluminum, copper, lead and iron. It should have high resistivity and low melting point. So now it says state Joule's law of heating. You remember I square RT? That is not just the Joule's law. You need to write everything about the heating effect of current, then representation of that by Joule's law, and then H is directly proportional to I square, directly proportional to R, directly proportional to T, H is equal to I square RT. Everything. Okay. So how is effect useful in electric circuits where fuse is used? Right here. Right here. So it says that if high current flows more than required, fuse wire gets heated and melts, and this can be written. So it came in CBSE 2024. Simple question, easy peasy, lemon squeezy. Okay. All righty. Here we are over with this particular entire chapter. We are going to practice the numericals, and we are going to talk about the revision of this entire chapter. Okay. I'll just go and have some water and come back.